I have not yet started. Good morning, everybody. We are waiting for the AICT officials to give us the green signal to start. After that, I will start. Let us wait for a couple of minutes. Okay, now they are asking me to start. Good morning, everyone who have joined in large number for this workshop on examination reforms, which is based on AICT examination reform report um, submitted by a select committee headed by Professor Ashok Shettar, the Honorable Vice Chancellor of Kerala Technological University. And since we happen to be his colleagues, you have been asked to conduct these workshops. And we have been conducting this workshop for the last 3 years because AICT is very uh, serious and giving a lot of importance to these examination reforms. I think some people are saying the voice is not audible. Let me get some quick response from the participants, whether I am audible. If I am audible to few of them, then it is a local problem. So Dr. Megha Trivedi has said audible. So many people are giving the response that I am audible to them. So if somebody has a problem, then they have to sort it out at their own end. Okay. So Professor Ashok Shettar is the Vice Chancellor of Kerala Technological University. In fact, I am not Ashok Shettar. I am Professor Prakash Tevri. Somebody mispronounced it as Tiwari. I am Dean Academics of Kerala Technological University. Since Sir is busy with some other work, so I am also engaging his session. And immediately after this, I will also uh, handle the session that will start with the importance of graduate attributes, that is understanding of graduate attributes. So with these few words, I would like to thank AICTE for giving our team this important task of sharing our experience with the faculty members of engineering colleges as well as polytechnics of all the states across India. And as I said, we have already trained nearly 11,000 faculty members by conducting these workshops right from December 2018. And since AICT is very keen on the success of this exam reforms implementation, it is continuously running these workshops so that people who have not participated earlier or faculty members who have joined to the teaching profession newly should be updated about what this examination reforms is all about so that implementation will be successful throughout India. With these few words, I would like to start my presentation. So the first session is all about overview. So in all the sessions which you are going to conduct for the next 2 days will be covered in brief in this session so that you will get an overview in this session, and later on each of the topic will be expanded in the subsequent sessions. Okay, here you are seeing the word student learning. Okay, and as faculty members, as academic administrators like HOD, principal, and as the regulators like AICTE and state higher education bodies, all will be concerned about student learning. And how a student learns? Student learns through an educational experience that we create during his stay in our campus. Okay, so he spends roughly 4 years with us. During these 4 years, through different educational experience, we help him to learn. It may be through chalk and talk, or it may be through overhead projections, or it may be through taking him to the industry visits or to field visits, or making him to do projects, laboratory work, or exposing him to open-ended electives or professional electives like that through various types of courses, and hands-on experiences, we help the student to learn. And in providing the educational experience, there are three key elements. One is the curriculum, that is the content that we are going to deliver. Second is the pedagogy, the various teaching learning methods that we use to deliver the content. And third key element is the assessment. So the how we are going to assess and know that whatever you are taught is learned by the student. So we'll have different assessment strategies like internal assessment test, which and also assignments, quizzes, course project, which you call as continuous internal evaluation, and of course there will be semester end examinations. So these are the three key elements: curriculum, pedagogy, and assessment, which are important to improve the quality of technical education. And this quality of technical education is possible only when there is an alignment between these three key elements. So when there is an alignment between curriculum and the appropriate teaching learning methods and assessment strategies, then that results in quality of education. Now let us look at how these three key elements are evolving. The first one is curriculum. So there is no we can say complaints about the curriculum being revised, because most of the universities and autonomous institutions are dynamically changing their curriculum. They are taking the inputs from the stakeholders, and in their board of studies meeting, they are proposing the curriculum, modified curriculum, and then it will be presented in front of the academic council or senate, which will review and approve. Then that curriculum will be implemented from the next academic year. So this process is going on, and there are, as I said, there are no complaints about the curriculum getting updated, because it is being done in the country on a dynamic fashion. The second key element is pedagogy. Pedagogy is all about the different teaching learning methods. The predominant method was the teaching learning method was chalk and talk. Then people started getting themselves used to using PowerPoint presentations. Then the various workshops were being conducted throughout India on active learning methods, where faculty members were taught how to engage the students in the classroom, which is very, very important. So the active learning methods like think, pair, share, or collaborative learning, or problem-based learning. So different workshops are being conducted throughout the country, but still very small number of faculty got exposed to these newer pedagogical methods. So we can say that the small changes are happening in teaching learning methods or pedagogy. Curriculum, absolutely no complaints, but pedagogy, things are happening, but on a lower level. Still a lot of faculty members need to be trained, and they need to practice. Okay. Then when it comes to assessment, then we can say that absolutely no changes. I graduated in the year 1984. So then if you look at the question paper and the current question papers, hardly there is any change. The type of questions that are asked then and now, there is hardly any change. Again, there are 8 questions, out of which 5 have to be solved. In some universities, out of 130 marks, they keep it for CIE, and 70 marks for SC. Again, there will be choices will be given to the students. So the things have not changed. The type of questions define something, explain something, describe something, discuss something, write short notes, and here and there some numerical problems are being asked. The same pattern is getting continued. So among the three key elements which are responsible for quality of education, Curriculum is happening on a dynamic fashion. Even AICT proposed a model curriculum for all UG and PG programs. But however, when it comes to other two key elements, pedagogy, very small changes, and assessment, which is important, but hardly there are any changes. Therefore, AICT felt the need for examination reforms, and then they constituted a committee under the chairmanship of Professor Ashok Shettar, Honorable Vice Chancellor for KL Technological University, Hubballi, Karnataka. And then the committee submitted a report which was accepted by the AICT and then become a policy document. Now we are trying to understand the different issues covered by this policy document so that implementation will be smooth and error-free. That is the idea. Then let us look at what educational researchers say about examination or assessment. Let me quote George Miller. He says, assessment drives student learning. See, there are three key elements, curriculum, pedagogy, and assessment, yet he emphasizes on assessment. Assessment drives student learning. Okay, so you also know as the faculty members, even if you have very limited experience of teaching, that students pay importance to those topics on which the questions will be asked in the examination. Okay. So therefore, assessment is important among the three key elements. Okay. Next is Ramsden. He says assessment drives what students pay attention to and defines the actual curriculum. As a student, you also experienced, and after becoming faculty members, it is you again. Your experience will tell you if there is a subject and most of the questions are descriptive type, and students will pay attention to descriptive type of questions only. And if there is a subject and in which out of 170 marks are reserved for numerical problems, then students will pay attention to practicing solving numerical problems only. So here, depending on the type of assessment, students, that will become the actual curriculum of the student. Even though there are 8 chapters, and there is theoretical portion as well as numerical portion, but depending on the type of old question papers which are available in the library, okay, if they are descriptive type, students will pay attention to that, to do only those topics. And if majority of questions are coming from another set of topics, then he will pay attention to that, and that will become his actual curriculum rather than the syllabus that is shared by the teacher with the students. Then the third researcher says the law of educational cause and effect states that for every evaluative action, there is an equal or greater educational reaction. Okay. So here, again, it is you can connect to your experience. Let's say there is a third semester, electrical engineering department, laboratory exams are going on. In India, it is the practice that when the laboratory exams are there, we invite external examiner. And when the first batch are attending, they are from the same class, but in batches, one batch is attending one lab, and another batch is attending another lab. So in one lab, let's say lab 1, the external examiner is giving a lot of importance to the student write-up, which you do in the first 30 minutes, what he has written about the EM apparatus procedure and sample calculation as well as circuit diagram. So he's giving more importance to this. If circuit diagram is correct, he's allowing the student to go near the table and conduct the experiment. Otherwise, he's sending them back from the laboratory itself. He's not allowing them to conduct the experiment. Another lab for the same students, third semester electrical students, their external examiner is allowing the students to conduct the exam, only is giving importance to YOS, the performance of the student during YOS exam. Now, what will happen immediately after the first batch, the news spreads, then the students, the way prepare the subsequent batches. For lab 1, students will practice the circuit diagram and the write-up more and more. And whereas for lab 2, they will practice more and more of Vivos questions and answers. So here we say that law of educational cause and effect, that for every evaluated action, the way you are going to evaluate the student, so that will influence the students how he's going to prepare for the examination. His educational reaction depends on that. Therefore, if you want him to learn something, then make it a part of his assessment. Then only he will pay attention to it and you learn. If you think that students should learn communication skills, bring this as part of your seminars, assessment, or project Vivos assessment. They say this much marks are meant for the way you prepare your PPT slides, the way you present, your body language, and your clarity, grammar free report writing, and a sequence of ideas, and how you are inserting the, the data given by other researchers, the figures, the caption, how you're writing for the table and the figures. All these things, if you say that these are important, then students come to know that, oh, I am going to get marks or going to lose marks if I don't learn these things and if I don't demonstrate this. Then he will pay attention to it. It will become part of his curriculum. And then he will demonstrate his learning in those things. Okay. So that is what is meant by this. For every evaluate action, there is an equal or greater educational reaction. Then finally, Donald Melnick, he says, curriculum instruct teacher what to teach, exam instruct students what to learn. So before the commencement of the new semester, okay, the head of the department conducts a meeting and then he will allot the subjects for the next semester. Then as a teacher, you collect the syllabus, you look at now so many chapters are there, and then what are the textbook, what are the reference book, that becomes your curriculum. Okay, whatever the HOD has given a syllabus copy, that becomes the curriculum for the teacher to what to teach in the coming semester. But whether the same thing when is shared with the student, will it become his curriculum? No. For the subject, he will collect the old question paper from the library and talk to his seniors. And seniors will tell, among these 8 chapters, these are important, these are the important chapters on which most of the questions will come. Now that will become the curriculum of the students. Then that will instruct the student to learn only contents of those topics. He will leave out other things. So therefore, this also we have come across, curriculum instructs teacher what to learn and exam instructs student what to learn. So if you want student to learn something, make it a part of examination. So all these researchers, what they are quoting, conveys only one thing. Among the 3 key elements, the curriculum, the pedagogy, and assessment. Assessment is very, very important because it drives the student learning. It makes those things a part of his curriculum, and he starts paying attention to only those topics which are assessed in the examination. And therefore, it is, as a teacher, it is our duty. If we think that anything is important for the student's career, we should make part of the assessment. Let it be communication skill, leadership skill, teamwork skill, project management, finance management skill, or his ability to learn on his own, or ethics, or use of modern tools, or his effect of engineering projects on society, or if nowadays the global warming, environment, sustainability are becoming important. If you want our students to be good at these things and become a good problem solver, analyzer, then all these things we have to bring them as part of assessment, either continuous internal evaluation or semester examination. Then only student will pay attention to it and make attempt to learn. Okay. Now, before going to the issues covered by this exam reform policy document, let us look at what are the key drivers for these examination reforms. One is the adaptation of outcome-based education framework. Most of the developed countries have already adopted outcome-based education framework. Because what we are seeing, the comments by industrialists, that only a small percentage of graduates in India are employable. And most of the graduates are not employable. Even though they have a degree certificate with them, they are not employable. Only because they are not meeting the expectations of the 21st century employers. So what is happening now, it has happened somewhere in the 80s in the developed world. So with a lot of deliberations, they decided to adopt outcome-based education framework, where the program educational objectives, program outcomes are defined first, and looking at the program outcomes, the subjects are selected, and for each of the subject program outcome, course outcomes are written. These course outcomes collectively help. They ensure that achieve the program outcome. Therefore, they do the CO program mapping. So this outcome-based education framework has been adopted by the developed countries, and it is giving good results. The students are becoming more employable, and curriculum, what is designed based on this framework, is meeting the requirements of 21st century. Whatever the technical outcomes and professional outcomes expected by the 21st century employers, they are conveyed by the professional societies like IEEE, ASME, American Society of Civil Engineers, ASCE, then American Society of Chemical Engineers, Biotechnology Engineers, like that. All the professional societies, in collaboration with accrediting agency, they have defined the 12 program outcomes, which are also known as graduate attributes for undergraduate engineering education. So now these graduate attributes or program outcomes, they are accepted at global level. Okay, they are not specific to any country. At global level, they are accepted, and 6 countries started what is known as become the permanent signatory of Washington Accord. These multinationals, they agreed and signed a document which is known as Washington Accord. According to it, the permanent members of this Washington Accord, they will recognize the undergraduate degree of engineering in their countries. If any member country is in a member country, the programs are accredited, and those graduates will be recognized by other member countries of the Washington Accord. Okay, so it helps in recognition of mutual degrees, and it also helps in mobility of the engineers. So that is what started, and even India was invited to become a temporary member in 2007 with the condition that in 2 years' time, India will demonstrate its ability to accredit engineering programs on outcome-based practices. Even though India became a temporary member of Washington Accord, even by 2009, it could not succeed in demonstrating its accreditation process through outcome-based practices. So we did not become permanent member by 2009. Again, they extended our temporary membership by another 2 years. Even though some awareness workshops being conducted, few of the colleges were started implementing. But even by 2011 also, India failed to demonstrate its accreditation process based on the outcome-based practices. So again in 2011, the temporary membership Washington Accord for India was extended by another 2 years. So 2013, something started happening. Now there was greater awareness about outcome-based practices, and many colleges were implemented able to demonstrate. Now, ultimately, India could be able to demonstrate and get the permanent membership of Washington Accord on June 2013, sorry, June 13, 2013. Okay, uh, sorry, June 13, 2014, India became a permanent member of Washington Accord. June 13, 2014. In 2014, it became, and re-accreditation of Indian accreditation process happened in 2019, and we happen to be one of the colleges for the Washington Accord expert to visit, and it visited our institution, so we are little more aware about how this process happens. So the key advantage of becoming a permanent member of Washington Accord is our degrees. If we are a tier 1 institute in India and you have got accredited and your program will be recognized by all the other member countries of Washington Accord. It could be UK, USA, Germany, France, Russia, Japan, China, okay, Malaysia, like that, the Australia, New Zealand, everywhere, our undergraduate degrees will be recognized. Okay, so that is the advantage. So one of the key driver for exams reform was we should also become a permanent member of Washington Accord so that our degrees will be recognized by other countries and it will be easy for our students to move to other countries and practice the profession of engineering. That was the first key driver. Second is growing concern about quality and employability of graduates. Okay, so earlier I said that industry people are making these statements that only 15% are employable, 20% are employable, 25% are employable, and they are also express the quality of graduates. Only a small percentage of uh, technical institutions are producing quality engineers and others are producing mediocre engineers, like that. The statements we often hear in media, which is quite disturbing as academicians. And the third driver was the importance of higher order abilities and professional skills for employability of graduates. So many of the employers say that there are a lot of jobs, but we don't have the graduates who are employable. The main reason they quote is technical education institutions are preparing students only for lower order abilities. So the lower order abilities and higher order abilities are differentiated in Bloom's taxonomy levels, as per Bloom's taxonomy levels. The lower levels are remembering, understanding, and applying. These three levels are known as lower order abilities or lower order thinking skills, and analyzing, evaluating, and creating are known as higher order thinking skills. Employers say that they are interested in graduates who are having higher order abilities. But if you look at your question papers, most of the questions are addressing lower order abilities. Define something, that is based on remembering. Then explain something, that is again it depends on the second level understanding. Or a scenario based question or another numerical problem which is not solved in the classroom, which involves the concept what you're taught in the class, but it addresses another context. So applying. Most of these are addressing lower order thinking skills. But employers are interested in higher order thinking skills like analyzing, evaluating, and creating, which are given less emphasis in our examination system. So therefore, they say that your students are good in lower order thinking skills, but what we need is higher order ability, which is missing in most of the students. Therefore, they are not employable. And also they say that most of the graduates from technical institutions lack professional skills. Nowadays, what is important is communication skills. The highest importance is given to communication skills. Not only just oral communication, written communication, and graphical communication. All these things are important. The student should be able to read and comprehend literature. They should be able to address technical and non-technical people to get the business. Okay? And then they should be able to write good technical reports. So these skills are missing. and also their ability to manage the project. The project management skills are missing. Okay, how to um, prepare a project plan, and if something goes wrong, what is the backup plan? All these things students are not aware, and how to execute a project within the limited budget and time, that is missing. And then our graduates lack how to manage a team. Okay, when you are executing a project, you are working in a team as well as sometimes you become a team leader. So how to work in a team and how to lead a team, these things are not uh, taught in the technical institutions to a level that is expected by these 21st century employers. So that is the concern for these uh, employers. Therefore, they say that there is a need for training the students in higher order abilities as well as professional skills. So these three uh, uh, drivers were behind these exam reforms. So keeping these key drivers in mind, that is already developed world has adopted outcome-based education framework, and employers have concern about the quality and employed graduates, and technical institutions are not training our students in higher order abilities as well as professional skills. Keeping these things in mind, the Examination Reform Committee came out with a report in which they addressed the three issues. One is assessment strategy for outcome-based education. Second is improving the structure and quality of assessment. And third is assessing higher order abilities and professional skills. So they did all these things so that the students will become better equipped with higher order abilities as well as professional skills. They become more employable so that the unemployment rate can be reduced. And they also wanted to see that the permanent membership of Washington Accord get extended and our degrees are recognized by other member countries so that our students can move to different countries and practice the engineering profession. Let us take one by one these issues addressed in the exam reform policy document. Assessment strategy for outcome-based education. Earlier, people thought that quality of the education system depends on the input to the system. They thought that they gave a lot of importance to input to the system. If input is good, they thought that output will also be good. Therefore, the regulatory authorities were giving a lot of importance to resources, infrastructure, and finances. Human resources like that. They used to say that the faculty student ratio should be 1:15. Infrastructure, there should be for every student 6 meter square area, instructional area. Then 1 meter square of admin area, 2 meter square of other amenity area. Then there will be 30% of this should be circulation area. Like this, they were instructing the input to the system. How many laboratories should be there? How many classrooms should be there? All those things. They used to think that if faculty is of that particular degree holder and in particular ratio to students and classrooms and laboratories and circulation area, if it is in that, and if finances are particular proportion, then if all this input is good, output will be good. But later on, they found that this one dimension doesn't help. It is not giving out students which are employable. Then they thought that is not just one dimension. The second dimension is also important. Along with the input to the system, what happens within the system is also important. Those were the days when ISO certification was becoming mandatory for industries. If you want to export to some European countries, ISO certification was a must. So there in ISO certification, they were giving more importance to process. Everything should be documented and the processes should be so well defined, which they call in corporate world standard operating procedures. They should be so well defined that it should not be person dependent, but should be process dependent. If processes are very good, even if the person changes, so his skills level, even if it changes, being a process very good, that will take care of the quality. So they used to give the example of preparing the rice in a open vessel. If a group of people were given uh, rice and a vessel and water and a gas stove to prepare the rice, the quality of rice cooked will vary from person to person. So am I audible now? Because I have changed the internet connection. Okay, thank you. Sorry for that technical hiccup. The internet connection went, so now I am connected through my personal data pack. Hope there will not be any problem now. So here they said that the process is important. No, instead of cooking the rice in open vessels, suppose if everybody given the same pressure cooker, same brand, and given the same instruction, 1 cup of rice, 2 cup of water, all the instruction how much time to cook. So till 3 whistles are given, then you have to put it in sim mode for so many minutes. Then you have to switch off and take out the cooker, and then after some time when it cools down, you have to open. Now you can say the cooked rice using this process will be more or less within small narrow band. The quality will be same. Definitely will be eatable. Yeah, the quality may still vary if the amount of precaution the people participants are using in measuring the water, it may, or rice. So there is small variation, but overall it will be good. Okay. So so therefore they said it's not just input to the system. The second dimension that what happens within system of process are also important. So then even then, after many institutions getting ISO certification, and their graduates are still, the employers have the same complaint. Still, they are not employable. There may be a marginal improvement, but still not to the desired level. Then they thought that proof of the pudding is in eating. So if output of system is good, then everything is good. So then they say that it is the quality of the graduate that is should be given emphasis rather than the input of the system. So earlier they talked about the output. Output refers to quantity. Then later on they modified it. It is not output, it should be outcomes. Outcomes refer to the quality. If I say 1 dozen of mangoes, it is output. Or a tree gives 1,000 mangoes, that is the output. But when I talk about the quality of 1,000 mangoes of very high quality, that is the outcome. So outcomes refer to quality, output refers to the quantity. So therefore, now initially they started output, then they changed it to the outcomes. So now the traditional emphasis was on input of the system, but nowadays the increasing emphasis is on outcomes. Therefore, now we are realized for quality of education system, it is a three-dimensional process, not a one-dimension or two-dimension. Input to the system is important. What happens within the system is important. Output along with the quality is also important. When these things happen, definitely the quality of our graduates will improve. They'll become more employable. So this was the first issue the exam reform document focused on. Now here, when you come to OB framework, there are 4 stages. The first stage is formulation of program educational objectives, which we call them as PUOs, and program outcomes, which are known as graduate attributes also. These PUOs and POs provide a clarity of focus for each of the engineering program. Be it civil engineering, program means here name of the discipline. Civil engineering, mechanical engineering, electrical and electronics engineering, electronics communication engineering, computer science, chemical engineering, biotechnology, like that. So these programs, when we write POs and program specific outcomes, it provides clarity of focus to these programs. So that is the first stage. Second stage is mapping the outcomes through curriculum. Having written the outcomes, next thing is we have to map these outcomes with the curriculum. Why? Okay, we have written the outcomes, but whether there is a content related to those outcomes or not. Okay, if I define outcome, let's say I have defined ethics is important for engineering graduates. And in my first to 8th semester in any of the course, if I'm not addressing ethics, so the graduates will be lacking that competency. They'll not be aware about what ethics is, what is expected from them. Similarly, if I want my students to be lifelong learner and if there is no content or any course which exposes the student to these lifelong learning abilities, and that competency will be lacking at the end of the program. Therefore, in order to ensure that whatever the program outcomes and program specific outcomes we write, it has the relevant content in our curriculum. Therefore, these subjects in the first column and in subsequent columns, the PO1, PO2, PO up to PO12 and program specific 1, 2, 3, 4 are written. Even though you have option of writing either 2 program specific outcomes or 4 program specific outcomes, and then they will be mapped. Okay, this addresses PO, this subject addresses PO1, this addresses PO2, PO3, this addresses PO4, this addresses PO5, 3, 6. Like that, you have to map. And when you look under each of the column, under each of the PO, none should be unmet. There should be 1 or 2 courses for each of the POs and PSOs. Then we say that our curriculum has enough content to address all the POs and PSOs. So therefore, this mapping becomes important, and this mapping of the courses with program outcomes and program specific outcomes is known as program articulation matrix. They call PAM, program articulation matrix. That is the second stage. And third stage is design and deliver aligned teaching and learning activities. Okay, you have defined POs, you have identified the content, you have written the course outcomes for this, but whether for each course outcomes, are you going to apply the same teaching learning method like chalk and talk or using a PowerPoint presentation? Let's say for problem solving is one course outcome, and another is you want to make your students good in oral communication. Are you going to tell in the classroom using chalk and talk what is how oral communication done? Is it appropriate? If you make your student good in oral communication, then you have to create opportunity for him so that he can come on the stage and deliver. And whatever the mistakes he is doing while giving a seminar or a presentation, you identify and give a feedback, which is known as formative feedback. Then he will work upon it, his weaknesses, and improve year on year. Then by the end of the fourth year, he will have got so much of input from you and you would have practiced so much, he will be good in oral communication. So the teaching learning method, what you use to convey some basic concepts or to teach some laws, will be entirely different from making the students good in communication skill or making him good in teamwork and making good in project management, finance management. So you have to use appropriate teaching learning activities to help him learn or become gain mastery in different program outcomes. Then finally, the fourth stage of OBE framework is assessing attainment of outcomes. Okay, we have POs, we have the content. Now we have used appropriate teaching learning methods. We have delivered. We have helped to help the student to master those competencies. But how to know that they actually attain those outcomes or master those outcomes? Therefore, then you should have different assessment strategies to know that whatever is taught is learned by the students. So these are the four stages. And since this is all about examination reforms, so stage 4 is important. So in OBE framework, the program outcomes, which are defined by accrediting agencies in collaboration with professional societies, which are nothing but the student capability at the end of graduation, they provide the clarity of focus. Through program outcomes, each program gets clarity of focus. You will come to know, looking at the program outcomes, that okay, our students should be good in applying knowledge of mathematics, science, and engineering to solve complex engineering problems. They should be good in analyzing complex engineering problems. They should be good in developing design solutions of complex engineering problems. They should be good in investigating complex engineering problems. So which are the subjects which help students in doing this? They should be good in using modern tools, software as well as hardware tools. So in which laboratory I am addressing modern hardware tools and software tools, then you look at your laboratory work, whether they are or not. If they're not there, then you have to procure, train your faculty, and in turn, faculty will train the students. So looking at these program outcomes, you'll come to know what is present and what is missing. If something is missing, then you have to bring in, make it part of your curriculum. Whether ethics is addressed or not in the present curriculum is missing, bring it in some context. If communication skills are given enough emphasis, it's okay, or else you have to enhance it, enhance it. Are you training students become lifelong learner? So if it is missing, then bring it in. So these program outcomes bring clarity of focus. Then this design of programs will always be top down. We start with program outcomes, identify the courses, that is which you call content. Then for each of the course, we write course outcomes. And we ensure that all the courses from first semester to eighth semester together, it may be theory course, laboratory course, project course, industry internship, field visits, all together. These course outcomes help us to collectively achieve the program outcomes. Okay. As for that, we use appropriate teaching learning methods as well as assessment strategies to see that all the program outcomes and program specific outcomes are attained by our students. When that happens, automatically the quality of graduates will improve and they will become employable. Therefore, in OBE, the program design is top-down approach. Whereas assessment will always be bottom-up approach. Because first you have to deliver the content, then only you can assess. So it is known as bottom-up approach. Design is top-down, whereas assessment is bottom-up. Then, in the earlier stage of implementation of OBE in our country, many things went wrong. That is, these program outcomes are high level generic to all the programs, may it be civil, computer science, E&C, mechanical, whichever branch of engineering, the program outcomes which are 12 in number, they are common. Only program specific outcomes are different, but mandatory outcomes 12 are common. But courses are specific to that program. Civil engineering courses are entirely different from computer science subjects. Similarly, computer science are different from mechanical courses. So, but we are writing course outcomes and connecting these course outcomes directly with program outcomes. Okay. Subject of civil engineering, something we are writing course outcome, we are connected to program outcome. Computer science, we are writing, we have teaching some course, we are writing course outcome and connecting that CO directly with program outcome. So because of this, courses are very specific to the program. Program outcomes are very generic to all the programs. And something which is specific, we are connecting to something which is generic and at a very high level. A low level, very specific outcome, we are connected to high level generic outcomes. So that was the missing connect. Therefore, earlier implementation of OBE, oh, it was existing only on the paper. We are saying that we are writing POs, we are writing POs, we are writing PSOs, we are keeping and we are doing COPO mapping, and we are keeping them in our course file. And teachers are going to the classroom and delivering the way they were teaching earlier. And questions per paper will also be say on the same pattern what used to be 10 years back or 20 years back. And students used to write. Only the marks scored by students were getting connected with the different outcomes, and then some using some technique, the outcome attainments were shown. So, but therefore, there was not much significant impact on the quality of graduates. So it is because our own understanding of connecting the CO with PO was not correct. So that was the missing connect. So you all know that these are the 12 program outcomes which are also known as graduate attributes. Since the second session I am going to elaborate, now I am just read the key words. The first program outcome was about engineering knowledge. Second was about problem analysis. Third was design and development of solutions. Fourth is conduct investigations of complex problems. Fifth is modern tool usage. Sixth, engineer and society. Seventh, environment and sustainability. 8 is ethics. 9 is individual and teamwork. 10 is communication. 11 is project management and finance. 12 is lifelong learning. So we used to say that these program outcomes give us clarity of focus for each of the programs. As I said, I will elaborate these things in my next session. So when India started adopting OBE framework, the one of the challenge for faculty members was, what are the expectations of the program outcomes for the students to learn and attain? Because program outcomes were looking like complex statements, like at the end of the program, students should be able to apply knowledge of mathematics, science, and engineering fundamentals to solve complex engineering problems. So when the faculty member read this program outcome, he was under confusion. As a teacher, what is expected from me? I am used to teach my subject. And in my subject, what I should cover, what are the expectation of the program outcome, and in what way I should teach so that my student will learn and show the attainment about this program outcomes. And again here the doubt. So for my course, I am writing some 4 to 6 course outcomes, and how these should be connected to the expectation of the program outcome, whether my course outcome should address all the 12 program outcomes and program specific outcomes, or whether I am permitted to write course outcomes which will address only 1, 2, 3 program outcomes. So these were the initial doubts in the minds of the faculty members. And since there were doubts in the NBA accredited people, again it is faculty members of some college, they were going as accreditors for other colleges. Since they themselves had doubts, Then they also putting some unreasonable expectations. Then teachers were getting still more confused. Some accreditors were demanding when you write a course outcome, it should be mapped with all the program outcomes. PO1 to PO12, everything you have to map. So if you're writing 6 program outcomes, all 6 program or course outcomes should be mapped with all the program outcomes. Now I'll ask a question. Like you are teaching a subject thermodynamics. What thermodynamics has to do with ethics? Are you going to address ethics in thermodynamics? Are you going to address teamwork in thermodynamics? Are you going to address project management and finance management in thermodynamics? Are you going to address teamwork and leadership in thermodynamics? So this is totally unreasonable. Thermodynamics may address PO1. And if there are problems related to analysis, PO2. And it's if you are using some software to analyze the air standard cycles and other things, it may address some use of modern tool. So it all depends upon how the teacher is using. But it definitely, you may increase the number of program outcomes your course thermodynamics can address depending on how you are designing your course. Okay, how you are teaching learning pedagogy you are using. Okay, but definitely it cannot address all the 12 program outcomes. So faculty, it must address at least one, because otherwise there is no need for that subject to exist in your curriculum. So a course should address at least one PO or two or three. If it addresses more and more, then the load on the teacher, responsibility on the teacher will increase. Now we have to understand more than 2-3 program outcomes. You have to understand what are the expectations of program outcomes. You have to design his teaching activities in such a way that through that educational experience, he will train his student in these POs. Now I ask question, why you want to take all the burden on yourself to train your student in all the program outcomes? Student is with you for 4 years. He is going to study 35 to 40 subjects. You are 15 to 20 faculty members in the department. So you distribute among yourself in which course you want to address which program outcome. So what responsibility teacher will take? Ultimately, the responsibility for the entire department, not 1 or 2 faculty members to address all the POs and PSOs. So you take responsibility of only some manageable program outcomes so that you can focus on the program outcomes, understand them in depth, design activities related to those outcomes or competencies, then deliver and help your students to show better attainment in those program outcomes. So, but these were the doubts and the faculty members having a lack of clarity. Since the faculty members are having the lack of clarity about these expectations of program outcomes, this lack of clarity at individual level became the lack of clarity at the system level, at the department level, at the institute level, because no department has the clarity of expectation program outcomes. So it became the lack of clarity at the institution level. Since different institutions are having lack of clarity, it became at the state level and national level. So that was one of the problem or hurdle in the implementation of correct implementation would be in our country in the beginning. Then going forward about this OBE framework, as I said, design is top-down approach. Then we also using appropriate teaching learning strategies. We try to see that the students show attainment in the program outcomes. Now, how well these program outcomes are attained depends on how well the course outcomes and topic level outcomes are attained. Because ultimately, the course outcomes help us to achieve the program outcomes. And course outcomes are attained through topic level outcomes. So if topic level outcomes are attained correctly, then course level outcomes are attained correctly. When that happens, then program level outcomes attainment will be better. So therefore, if when we design the assessment questions, if the assessment questions are connected properly with the course outcomes, then course assessment will be better. And if course assessment is better, then program assessment will be realistic. So our assessment strategy should be such that we have to give more and more emphasis on attainment of course assessment. How well we define our questions, or how our assessment, whether continuous internal evaluation or semester examination, how we prepare our question paper, what is the structure and quality of this question paper, that determines the, the attainment of course outcomes, which in turn determines the realistic program assessment. So this was the missing connect in the earlier stages of adaptation of OBE framework. So later on, this factor will be elaborated in the second session as well as the fourth session. So this was the missing connect. So weakest link in adaptation of OBE framework was realistic measurement of attainment of outcomes, both at course level and also at program level. Since measurement was not realistic, so whatever the attainment we are showing, whether on a scale of 0 to 3, whether we are showing 2.8 or 3 out of 3 or 2.7, it was not realistic because measurement themselves were not realistic, attainment were also not realistic. So then the panel decided how to help the faculty members to overcome these challenges in connecting POs to assessment. As earlier I said, the programs represent fairly high-level generic goals. Generic means they're common to all the undergraduate engineering programs, and they are not directly measurable. Since they are very high level and generic, they are not directly measurable. Therefore, a realistic observability and measurability of the POs at course level is very difficult. Okay. So then they thought it is necessary to bring further clarity and specificity to program outcomes. For this, they proposed two-step process. This is the heart of the exam reform policy document. So please pay attention to it. The two-step process. So earlier, many of you may be knowing what the program outcomes are. In this exam reform policy document, they said that for each of the program outcome, first you define the competencies. What are the expected competency of each of the program outcome? First you list them. Then for each of the competency, you write what are the performance indicators. The first step, writing the competencies for each of the program outcome. Second step, writing the performance indicator for each of the competency. Let us see what these two steps are. The first step is about competencies. Competencies are nothing but implies different abilities to be attained by the learner. So a task is given to a person, one who is having the ability to complete it. Okay. If I were given the task of teaching a subject, okay, I will do it. Being an academician, I will do it. If it falls under my domain, I will do it. But if they ask me to do a painting for which I don't have the competency, definitely I will not be able to do it. So for each of the outcome, there are certain abilities which are implied in the statement itself that we should try to read, understand, and make a list. That's why we say identify the competencies expected by the program outcomes. So let us try to understand these competencies with an example. Let's PO3, irrespective of the branch of engineering, you are training your students in design and development of solutions. The PO reads like this: design solutions for complex engineering problems and design system components or processes that meet the specified needs with appropriate consideration for public health and safety and cultural, societal, and environmental considerations. So we have to train. The statement is a little bit complex. First, we should develop the clarity about the expectation of this program outcome. Okay, so you should know what the complex engineering problem is. So what are the implied different abilities by this PO? Say that by the end of the program, the student should have the ability to define a complex open-ended problem in engineering terms. Suppose if you take him to an industry and if there is a problem faced, he should be able to study the situation and define a complex open-ended problem. That is known as ability to define a complex open-ended problem in engineering terms. Second, he should have the ability to generate a diverse set of alternative design solutions. He should be able to propose more than one solutions. Then he should have the ability to select optimal design scheme. So if he is able to come out with 2-3 solutions, out of that which is best, using particular tool, he should be able to say for this reason this is the better solution. Then he should have the ability to advance engineering design to define, and having selected, he should have the ability to design so that the problem is solved. So if the student has these abilities, then only we can say that he has shown the attainment of PO3. Earlier, in the earlier stage of OB implementation, they were not identifying these competencies. So PO3 is written, so they are giving some problem, design problem. It could be well-defined problem that everything, all the data required to solve the problem may be not given. So it doesn't satisfy the definition of complex engineering problem. And students are solving that. And faculty member is to map it to PO3 and to say that the students are trained in PO3. So the first faculty members are not knowing what a complex engineering problem itself is. And even a well-defined problem, they are calling it a complex engineering problem, or they're getting confused that that itself is a complex engineering problem, or they're confusing that if the problem is difficult, that is a complex engineering problem. And then if the students are able to solve and get marks, they used to say that PO3 is attained. And they are not aware about these were the expectation of this PO3. In terms of abilities or the competencies, they were the expectation of PO3. So in this examination policy document, from page number 15 to 19, for each of the PO, they have identified these abilities which they call them as competencies. You need not have to do this effort. Already some other faculty member group has taken that pain of reading these program outcomes and identify the abilities and expressing them as competencies, and they are available in exam reforms policy document from page number 15 to 19. So this is the first step. For each of the PO, identify the competencies. And second step, for each of the competency, write the performance indicators. What is the performance indicators? These are explicit statements of expectations of the student learning for each competency defined. Okay. So there are explicit statements of expectations. They can act as measuring tools in assessment to understand the extent of attainment of outcomes. Earlier I said POs are high-level generic. If you want to understand in management terms at 50,000 feet, and when you write the competencies will be at 25,000 feet. When you look at a higher level, at a ground level, very little details you are able to see. But from 50,000 feet, when you come to 25,000 feet, when you see, things will be more clearer. Therefore, we have to identify the competencies. And for each of the competency, now you have to write the PIs, performance indicator, which are at the ground level. Because they are explicit statements of expectations. Okay. So these performance act as measuring tools in assessment to understand the extent of attainment of outcomes. When we ask questions, we are very specific what answer we want. So their questions are also explicit statements of our expectations. And PIs are also explicit statements of expectation. So you should map the questions you ask either in your assessment with the PIs, not with the COs directly. So this is how the PIs help. The questions what we ask should be mapped with the PIs first. PI in turn get mapped with the competency. competency in terms with the PO. That we'll see a little later. For example, here there is a competency 2 for PO3, ability to generate a diverse set of alternative design solutions. So to generate alternative design solutions, the student should have the ability to apply formal idea generation tools to develop multiple engineering design solutions. So in the classroom, you should teach him bug evaluation method or morphological chart so that he can come out with alternative design solution for the given problem. Second, he should be able to identify the functional and non-functional criteria for evaluation of alternative design solutions. Some technical issues, some cost issues, some size issues, okay, whether the availability of electricity, with electricity, without electricity, or different criteria you can put, and based on that, depending on the local situation, you should be able to identify which is the best alternative design solutions. So this is the how you can write performance indicator. Again, you need not have to do anything. Already for each of the competency, performance indicators are defined, and they are also available from page number 15 to 19 in AICTE exam reform policy document. Okay. So why this two-step method is important? What are the two steps? First step is for each of the PO write competencies, and for each of the competency write performance indicators. So these are two steps. Writing competency and performance indicator is known as two-step. Using the two-step method, it brings a clear understanding of the expectation of each program outcomes to faculty and students. So it is not just for students, it is for both faculty and students. Then connecting course outcomes to performance indicators and hence to POs will be easy and accurate. Earlier what I said, missing connect, that problem will be overcome if you use two-step method. So you knew, already you know, because many of you have started implemented OB in your colleges for the given course, let it be thermodynamics, let it be machine design, or structural engineering, or signal science system, software engineering. What is the subject you are teaching? You know how to write course outcomes. With the knowledge what you're going to gain by attending this workshop, you're going to connect these course outcomes with performance indicators. And since performance indicators are explicit expectations and exam questions are also explicit expectations from the students, the questions should be connected to the PI. Earlier, you were connecting examination question directly with COs. Now, in between, you bring PIs. So this PI comes because of two-step process. For a PO, you are writing competency, and for each competency, you are writing PI. So that PI will be connected with the questions, and PI is connected to CO. And when students take the examination, write the answers, based on their performance, you assign a marks. Based on that, you see what are the PIs are met or unmet. Then through that, you can assess the course outcomes, and course outcomes are mapped with program outcomes. And different courses may show the mapping with the same program outcomes. Like physics also is mapped with PO1, chemistry also PO1, then mathematics course also mapped with PO1. So therefore, weighted average method is used to show the attainment of program outcomes. So by mapping examination questions with performance indicators, this one, by this step, we get clarity and better resolution for the assessment of COs and POs. So whatever unrealistic measurement was there, that problem can be overcome by this strategy. That was the first issue addressed by exam reform policy document. The second issue is improving the structure and quality. Structure refers to the alignment issues, and quality refers to cognitive levels issue, Bloom's taxonomy level issue. Few decades back, when we became graduates in the 80s or late 80s, if somebody was asked who is a good engineer, then they used to say the one with good technical capability. But now, the expectations of 21st century employers are growing. Along with technical capability, they want leadership ability, teamwork ability, problem solving skills, critical thinking skills, lifelong learning skills, ethics, social responsibility, communication, like that. Apart from technical ability, they want many professional skills. And here I want to draw your attention to the quotes given by educational researchers. Assessment drives student learning. Okay. The curriculum instructs what teachers, curriculum instruct teacher what to teach, and exam instructs student what to learn. So if you want your student to pay attention to this and then show his learning, and I want them to make these things part of his curriculum, then all these things should become a part of your assessment. Whether it's a continuous internal evaluation or semester examination, these things should be addressed. Then only student will pay attention. They will become part of the curriculum, and they will make attempt to learn and demonstrate. So therefore, those four quotes were shown earlier. So 21st century employees' expectation have grown. So therefore, our exam reforms are already late, but it should not be further delayed. Without any loss of time, we must implement. So the 12 program outcomes I have already shown. Right? The first 5 are known as technical outcomes, and the next 7 are known as professional outcomes. Looking at this, many of the colleges say, no, these technical outcomes we address. That's not a problem. Only recently we have started emphasizing on, giving emphasis on these professional outcomes. Even when we say we are addressing the technical outcomes, are we doing justice? Because here they say that ability to provide solution to the complex engineering problems. When you are solving complex engineering problem, definitely it will address higher order abilities. So when problem analysis, there also they say complex engineering problem. Design and development, complex engineering problem. Conduct investigation of complex engineering problem. Modern tool usage for modeling complex engineering problem. And many times faculty members not aware what a complex engineering problem is. So because when you don't know what a complex engineering problem is, then how we are going to prepare our students to solve complex engineering problem, analyze complex engineering problem, design solutions for complex engineering problem, investigate complex engineering problem, and model complex engineering problem. Complex engineering problem is one which do not appear at the end of the textbook chapter. However difficult it is, that the problems or the questions which appear at the end of the textbook chapter are only to test the mastery of the content of the chapter. So it is not a complex engineering problem. Complex engineering problems are those which are not well defined. If all the data is available to solve the problem, then it is close, well defined problem. It is not ill defined problem. Complex engineering problems are ill defined. Something is deliberately not defined. The student has to make an assumption or a choice. Only when he makes a choice, the definition becomes complete, and accordingly solution changes. Okay. Suppose if you ask students to design a chair and without specifying the material, one student will assume that wooden chair. Accordingly, looking at a property of wood, he will design the thickness and everything what is selected will be different. And they will take aluminum as a material. So because of property of aluminum are different, so the thickness of aluminum sheet used, everything will be different to withstand the same load. And they will do GI sheet. And they will use material as plastic. So based on these assumptions or a choice, the entire the solution changes. But all solutions will meet the requirement of withstanding 150 kg, if that is the expectation of the chair. All 4 chairs designed will take the load of 150 kg. But the design materials are different, so the thickness, other things, everything will vary. So in this way, have we trained our students? And while solving, whether is use the laws of science as well as mathematical tools. So when the problem is not appearing at the end of the chapter in the books, and when it's ill-defined, and when it demands use of laws of science or mathematical uh, modeling mathematical modeling or methods, then only it is a complex engineering problem. Then only we say that we have actually trained students. So here also, when we say we are addressing technical outcome, still there are gaps which need to be bridged. And you all know in the present exam system, memorization occupies the dominant place. Okay, most of questions are such that even if a student do not understand, if he buy it and comes, and still he can pass and get first class. We are not saying that memorization is not important. The recall of factual knowledge is essential because every time you cannot refer to the book. If you know that PV is equal to MRT, it is good. You can solve the problem. If you know that aluminum, copper are good conductors, okay, where plastic is bad conductor, is good. You can take quick decisions. So this memorization is good, but that is not sufficient. It's necessary, but not sufficient. Along with memorization, many other abilities are required to be demonstrated by graduates. Like you should have the ability to apply knowledge. You should have the ability to solve complex problems. You should have the ability to analyze complex problems. You should have the ability to synthesize complex problems. You should have the ability to design complex solution for complex engineering problems. So along with memorization, we also must uh, train our students in higher level abilities. So for that reason, we have to use Bloom's taxonomy in designing the question papers. So since tomorrow first session will be entirely on Bloom's taxonomy, so I'm not going to go in details. It is only I can say it is a popular framework in engineering education to structure the assessment as it characterizes complexity and higher order abilities. Okay. Our question paper should go beyond testing memory recall. It should also test higher order abilities. And what is lower order ability? What is higher order ability? There are 6 levels: level 1, level 2, level 3. They are lower order abilities. Analyzing 4, evaluating 5, creating 6. The 4, 5, 6 are known as higher order abilities. And when you want to assess them, preferably in fixed hour examination like internal assessment test or semester examination of 3 hours, better, or 2 hours or 3 hours, whatever is fixed hour exam. You ask questions related to lower order abilities, remembering, understanding, applying, and if you are can also manage to ask few questions on analysis. But if you want to really test your students for higher order abilities, then don't ask them in fixed hour exam. Better ask questions related to higher order abilities in post projects, mini projects, minor projects, capstone projects, and open-ended problems. Okay. As tomorrow, as I said, there will be one session on this Bloom's taxonomy and design of question papers. The third issue addressed by the exam reform policy document is assessing higher order abilities and professional skills. As I said, many of the employers were complaining that the undergraduates of technical institutions lack the knowledge of higher abilities like analyzing, evaluating, and creating. And also they lack professional skills like communication skill, teamwork skills, project management skills, lifelong learning skills, and this ethics and engineer society and environment sustainability issues. They are lacking these professional skills. And even when you say that we are good in addressing the technical outcomes, but we are not addressing the higher abilities adequately, because these questions related to these things, these levels are not addressed adequately in our assessment questions. So what are the challenges in asking questions related to higher order abilities? The main obstacle is in addressing these outcomes is a limitation of education experience we create within our engineering programs. See, if you want to ask students about analyzing, evaluation, and creating, first in the classroom, we have to give that education experience. Without giving that education experience, how we are going to ask questions? without giving that education experience, if you simply ask, no exam reforms policy document asks, we should ask questions related to analyzing, evaluating, and creating without addressing them in the classroom, then student performance will be very poor and most of the students will fail and it will be a disaster for your profession as well as your college survival. Okay. So first we as a teachers, we have to understand how to address these higher order abilities in the classroom, what type of questions we should take, what type of questions we should solve in the classroom so that students will be or give us an assignment and help them students solve them so that students are trained in higher order abilities. Then we can ask them either in course project, mini project, minor project, or final projects, or open lab experiments. We can ask questions related to higher order abilities and show the attainment of program outcomes. Okay. So if you look at most of coursework in our program, they are oriented towards teaching technical knowledge and skills in a typical classroom and laboratory. As a teacher, we spend a lot of time in classroom when we are teaching theory courses and almost all the time in laboratory when teaching laboratory courses. And what is possible in this is mainly we are addressing the first three levels, remembering, understanding, applying. And that too we are going to solve problems from textbook only. Then with this, it is very difficult to address higher level abilities with our conventional examination system because there is a time constraint within that. For internal assessment, it may be 1 hour or 1 hour 15 minutes, and semester exam, it may be 2 hours or 3 hours. Within that limited time, if you ask very higher order ability questions, where students have to make some choices, accordingly, you have to select the properties and go through alternative solutions and select the best one and then solve it. So it is a time-consuming process, and real-world problems are iterative in nature, and is not possible in our fixed our conventional examination system. So therefore, we have to first make attempt in training of students, and only through those methods like course project, mini project, minor project, final project, open lab experiment, should test higher order ability questions, not with the conventional exam systems. And what about the professional skills, the program outcome 6 to 12? Again, these are very difficult to acquire in the classroom. Okay? If you want to train your students in teamwork, you cannot simply write the points, bullet points on that board. These are important for teamwork, these are important for leadership, these are important for communication, oral communication, written communication. Students will listen and forget. So they can be learned only when they are part of the team, when they're giving a presentation. Okay. So during a particular setting, they can learn not while listening to the lecture in the classroom. So therefore, we have to select appropriate teaching learning methods to train our students in these professional skills. Then only we can assess them. And again, they are difficult to assess through our conventional exam system. They should be assessed through use of rubrics. So tomorrow, in one of session, rubrics will be addressed by my colleague. So to address these challenges, comprehensive exam reforms are needed in the way we design our curriculum because it should be top-down approach looking at the program outcomes we have to design, not simply just a textbook is released in particular subject we should take and make it part of our curriculum. No, looking at the program outcome, select the we have to design the curriculum. Having designed a curriculum, you should use appropriate learning experiences to train our students in different competencies. Then in order to know whether they have mastered or not these competencies, we have to come up with assessment of the outcomes. So this is what we talked. So reforms in education experience. Three key elements are important: curriculum, pedagogy, and assessment. For that, we have to give more and more emphasis on experiential learning, contextual learning, and situated learning. Like in a industry internship, which is situated, he's already in the ecosystem where many of the professional outcomes are tested. Because during internship, he has to participate in team meetings, whether he is attending all the team meetings, whether he is attending in time, whether he is attending with full preparation or not, whatever the work that is assigned in the previous meeting, is he doing it or not? It talks about his attitude. Okay, if he's not meeting regular meetings, if he's not attending with the preparation, completing the task given, that shows the attitude. If it's positive attitude, then he will satisfy the requirement. If it's negative attitude, only after repeated reminder he will do something, and even if he may not do it to the satisfaction of his leaders. Therefore, many of the program outcomes can be tested in project work and in courses which are context, like if your city is known for a particular product, you can design some of the courses around that product so that students will see what is happening in the industry, so and they can get connected with the theoretical concept what you're teaching in the classroom and what they're seeing in that industry. So it helps in learning. So it all needs a lot of effort from the teachers. It just doesn't come just like that. So one has to uh, design the courses in such a way. For example, in Hubli, in Karnataka, it is known for valve industry, valve which are small for fluid control, but very big, even in nuclear industry, which are required. All will be designed at design manufactured at Hubli. So it is on the world map of valve industries. So since our college is situated in Hubli, when teaching some courses, design courses for mechanical engineering, we take examples of valves. The mechanism which are used in valves, the material selection. When teaching material science course, the materials which are used in valves are used. Deliberately, they are connected with that. Okay, and when design problems are given, they're designed with respect to this industry only. They're given. So when students see the concepts, learn the concept in the classroom, and visit the industry, spend some time, they'll be able to connect. In this way, they will be able to understand the concepts of the material science, then the machine design 1, machine design 2, and other analysis, CFD analysis, everything in a better way. So that's what we mean by contextual. Okay. So few educational experiences that are recommended to teach and assess professional outcomes. Earlier also I said, again it's repetition. You have to use course projects. As a part of your course only, if there are 50% internal, 50% semester exam, out of 50 marks, take out some 30 marks and give it for course project. What are students do? Define the problem in the first week of the semester, let the student take the entire semester to complete the project. So during this, he will learn. Uh, Situated, I talked about internship. So already in that ecosystem in the industry is there, where his program outcomes like teamwork skills, leadership skills, communication skills, report writing skills, ethical issues, all will be tested. And some things which he has to learn on his own and demonstrate that lifelong learning skills. And a project will be completed within 2 months or 3 months. That project management skills, everything will be tested in a situated environment. Okay, during internship. Or else you can do it in project implementation if properly designed at your own institute. Then course project, open experiments, project-based learning, nowadays gaining importance, PBL method, MOOCs courses. So there are many platforms available. Our own Indian Swayam platform, NPTEL, Coursera, edX. So many platforms are there through which you can learn and demonstrate your ability to learn on your own, lifelong learning skills. Co-curricular experiences, okay? Especially they are very important for MBA graduates, whatever the management skills they are taught. So when fair is conducted in their city and something at national level, if for international found, look at the Kumbh Mela, how it managed, okay? Crores of people attend, how the entire supply chain is managed, and how waste management takes care, how the health of people is monitored, how if people are lost are again taken back to their parents. So there are a lot of issues involved in conduct of the big fairs. So students can apply their management concepts in managing these fairs, or even at college level, the fest activities. So during this also some of the communication skills, ethical issues, that some money is sanctioned for an activity, whether they are uh, honest in giving the submission of bills or inflate the budget, a bill amount, and take the percentage out of it. Ethical issues, everything can be used as co-curricular experience, can also be used to test some of the program outcomes. Apart from that, mini and minor projects, final projects, internship experience, e-portfolio is very common in architecture students. So these experiences need very different tools for assessing student learning. So after listening to all these things, some questions may arise in your mind. Can our student handle this? Okay. Higher level abilities or proficient skills. So right now you are addressing lower order abilities. And if you start addressing higher order abilities like uh, analyzing, evaluating, creating, and proficient skills like team management, leadership, communication skills, project management, finance management, all those things, whether our students can handle this. As it is, their performance level are low. Now, see, we have implemented OB in our institute right from 2008. So the more than 12 years experience we have. With our experience, we can confidently say it is not the problem with the students. They will just raise to the level we set for them. So problem is with us, the teachers. First, we have to learn what are the expectation of program outcomes. We have to design appropriate learning activities, and then we can train our students and assess them for the higher order abilities and professional skills using these methods which are shown here. Using these methods, if you test higher order abilities and professional skills, then students will definitely do better. So we have to set the standard which today's world and employers need. What is the point in producing large number of graduates who are unemployable? Rather than, it is better to produce graduates who are trained in all the program outcomes and program specific outcomes, and who are having high employability rate. So therefore, we say that these examination reforms are systemic in nature. What I mean by systemic in nature means this implementation of OBE or exam reforms cannot be done by one or two faculty members in the department. It should be done by all the faculty members in the department, all the departments in an institution, all the institutions in the state, and all the states in a country. So systemic reform. Therefore, AICT is very keen on spreading awareness of these examination reforms throughout the country, so that if you come out with a policy document and ask all the colleges to download from the AIC website, they can do it. But many questions will remain in the minds of the faculty members as well as HODs, principals, and ultimately implementation will fail. In order to overcome this, the AICT is conducting for the last 3 years. It is not just this year. For the last 3 years, continuously AICT is conducting these examination policy document workshops for faculty members of engineering colleges, MBA, polytechnics throughout India. So at the end, few suggestions, few action points for after the workshop for teachers. Based on the input what you receive from this 3-day workshop, have a relook at the structure and quality of the assessment for the course. For the course means subject. For the course you are teaching. If you are teaching particular course, you just have a relook at the question papers, what you are designing. What type of questions you are asking, and what are the expectations of this exam reform policy document at the end of this workshop. Come up with new question papers that are in line with reform report. Okay. Then share these question papers what you design with the AICT. AICT will provide a link to share your questions tomorrow in the afternoon. Using that, you share the questions. And also think about new education experience you need to bring into your course to create opportunity for embedding higher order skills and professional skills and experiment them in your next delivery. In next semester, when you teach a course, try to address higher order abilities and some professional skills in which you are comfortable addressing them in your course. And for your institution, some action points: intense orientation of faculty and academic leaders to adopt these reforms. You may be 2 or 3 people attending this, but at institute level, you have to train all other leaders, HODs, principal, everything. Everybody should be familiar with this to make it a success. Then come up with your own institutional document defining the assessment guidelines based on recommendation of the space available to you. Then start with continuous internal evaluation, because some of you may be affiliated colleges, some may be autonomous colleges. So affiliated colleges do not have freedom to design the question paper or design the course. So they can only experiment with internal evaluation. So you start with that, and with the experience you grow. Enhance experiential learning experiences and also weightage. If you are earlier, if you are only 10 credits are for projects, increase it to 15, 20, 25 like that. So that will give you more experiential learning for the students. So number of credits assigned to project work, mini project, minor project, you increase, course project increase, so that most of the things students learn while doing. They learn while doing the project rather than listening to the lectures in the classroom. Finally, use IT technology to effectively implement this OBE, because attainment calculation is a tedious work. If every teacher has to do what is the CO attainment, what is the PO attainment, then a lot of time is required. Instead of that, use a software that are available in the market. You can assess, select the best one, what you need, you are happy about, then use them, so that once you correct the internal assessment question paper, answer books, as well as semester and examination answer books, simply feed the marks of the questions, 1A so much, 1B so much, 2A to all this, then run the program automatically to show the attainment. In this way, use the IT effectively to implement. And university, some action points are the workshop: intense orientation of board of studies and board of examiners of universities to be trained in these reforms. And university has to come out its own university document. AICT has come out with the AICT exam reform policy document, and they say that it is a guideline. And referring to this guideline, if you want to make some changes to suit the local conditions, you can make those changes and come out with your own assessment guidelines. AICT says L1, L2 level, that is remember, understanding question, should be 40%. And L3, L4 level, applying and analyzing, should be remaining 60%. You look at your local conditions, whether you want to go directly 40-60 or whether you want to 50-50 or 60-40, then within 1 or 2 years you come back to AICT recommendation to 40-60. So in this way you come out with your own university document. And universities, since they manage a large number of institutions, they should also use IT effectively to implement it. And they should also, since they have more power to design the curriculum, they should assign more number of credits for experiential learning, that is mini project, minor project, course project, and final year projects. That will lead to holistic assessment. All these things what I discussed, they are available in this AICT exam reform report as well as document, which is available on the AICT website. I would like to end the first session with the 2 quotes One, assessment drives student learning. Therefore, exam reforms are important. And curriculum instructs teacher what to teach. Exam instructs student what to learn. So it is by Donald Melnick. So if you want student to learn something, make it part of his assessment or exam, then only he will learn and become more employable. So with this, I end the first session. And if you have any doubts, I can spend a few minutes. How to get Washington Accord for our program in BTech Biomedical Engineering at Northeastern Hill University, Shillong. Let me tell you, Washington Accord is for the country, not for individual program or college. Whether India gets membership of Washington Accord or not, whether England gets membership of Washington Accord or not, whether China gets membership of Washington Accord or not, it is for the country, not for the individual college or programs. So if country has to get Washington Accord, first they have to prove that they implemented OBE in their country. The technical institutions offering undergraduate engineering program, that is BE or BTech, in that country, they are practicing OBE in their institutions, and accrediting body in our country, National Board of Accreditation, that NBA, is giving accreditation based on the outcome-based practices. Therefore, in NBA, if you look at the self-assessment report, 400 marks are for OBE, remaining 600 marks are different, okay, for other things. So, and you know that out of 1000, if you don't get 600 marks, your program will not be said as NBA accredited. Okay? So, therefore, for Washington Accord, a team will come, an expert team appointed by the committee, a 2-member committee or 3-member committee will come, and NBA team will visit a college, tier 1 college, okay. Tier 1 means which is either university or autonomous college. So NBA team will be doing its assessment accreditation process as usual, okay. It will be doing, but these experts of Washington Accord, they sit at a distance and observe. They do not ask anything to any questions to the college which they have visited, nor they will talk with the NBA experts. They simply sit as observers. How our NBA accreditors ask questions, assess the data, and what type of process, the day 1, day 2, day 2, day 2, how they prepare the report, how the individual evaluator prepare the report, how the chairman prepare report, how the marks are allotted, how the program outcome, course outcome, assessment is carried out. Everything is when these people are doing, they simply observe. And if they are happy with the entire process, they extend the membership to the country, or else they say that these are the deficiencies, so therefore will not uh, uh, extend the membership. So NBA experts, they look into everything, attainment of CO, attainment of POs. The Washington Accord experts only look at the way in which our NBA experts carry out the process of accreditation. Okay, hope I've answered your question. Okay, when I take the second session, I will address how to get more on this analyzing, evaluating, creating. I have a specific example. I will go through it. So now let's say the session 1 is over. We'll take a break of 15 minutes. Now it is almost 11:30, 12:35, 35, 45, 50. Okay. At 12:50, we'll reassemble for the second session. I will take more questions during that session. It is an overview. It covers the entire thing, exam reform policy document as a whole. So in the second session, it is specific to program outcomes. I will address more on this. And tomorrow also my colleague who talks about Bloom's taxonomy, he will in detail, he's going to talk about each of the levels. What is each level and what type of questions and everything will be discussed tomorrow during the first session. Okay, let us stop the first session here and meet at 12:50. Good afternoon and warm welcome to the second session of the day one. Hope you are back. Shall I start the second session? May I get few responses?
Yes, sir. Yes, sir. Please.
Okay, thank you. Thank you very much. So, in the first session, we had an overview of entire AICT exam reform policy document. Now, we'll take up one issue at a time and expand it. So, this session's title is Need for Outcome-Based Education and Understanding Graduate Attributes, Competency and Performance Indicators. Okay. So already some of the points are already covered. Just for continuity, earlier what used to happen, or Honorable Vice Chancellor used to have the first session, I used to conduct the second session. But since I'm doing both, many of the points which I wanted to cover in the second session already I have explained them. So I'll be a bit fast during this session. I don't want to repeat the same thing again and again. Here I have listed 5 reasons for adaptation of outcome-based education in our country. One is to remain competitive at global level. Earlier I said that already the developed world institutions, developed and many of the developing countries have already adopted to outcome-based education framework because it addresses the outcomes as defined by the academic agency along with professional societies. The graduates coming out of this framework are better equipped both in technical and professional skills, and they have an edge over graduates of other colleges or graduates of other countries. So if India do not adopt outcome-based education, we will lose the competition. Therefore, to remain competitive at a global level, without any further delay, we have to adopt outcome-based education. That's the first reason. The second is to remain as a permanent signature of Washington Accord. I said that to remain permanent Washington Accord, member of Washington Accord, then the technical institutions have to implement, practice outcome-based education, and our accrediting body, NBA, had to demonstrate to the expert team of Washington Accord that the process that is used to give accreditation to different programs in our country are as per the outcome-based practices which are acceptable to Washington Accord Committee. Okay, so they come as observers, and see how the accreditation process happens in India. Make a note. Complete 3 days they will be along with the NBA experts, but they don't participate in the discussion. They only observe, and they send a report confidentially to their central committee, and it will be discussed, and then they take a decision. And why this permanent membership is important for India? One is our programs will be recognized by other member countries, and second reason is mobility of our graduates. You know that America is having $22.5 trillion economy, okay, and enrollment is only 100,000. That is 1 lakh students enroll for undergraduate engineering programs. India is just now 2.5 to 3, almost $3 trillion economy, and every year 15.5 lakh students enroll for engineering. So smaller economy, large number of students; larger economy, small number of students. So definitely when the economy is smaller scale, all the students will not able to get the job. So if we remain as a permanent signatory of Washington Accord, our degree is recognized, and our students will get better job opportunity in other member countries. So from that point of view, it is essential for India to remain permanent signatory of Washington Accord. Our degree is recognized, and our graduates can move to other countries. Third is to get NBA accreditation. Since The membership of India is connected with uh, Washington Accord membership, and for that NBA has to demonstrate its accreditation process based on outcome-based practices. Therefore, if as institute you do not practice OBE, then our NBA will not give accreditation to us. So to get NBA accreditation from NBA, we have to practice outcome-based education. Next, to adopt an education framework that helps in building learner competencies and makes students lifelong learners. Earlier, education, when at international level they used to discuss, they used to refer education as transfer of knowledge from an expert to student. They used to refer to education as transfer of knowledge. But now, when it after implementation OB, they no more refer to as transfer of knowledge. They refer to as a framework that helps in building learner competencies and makes students lifelong learners. And just now, in the first session, we saw the outcomes are in OB framework, outcomes are defined, and for these, each of the outcomes, competencies are defined. Okay, so if there is any framework which addresses competency and makes the student lifelong learner, in fact, lifelong learning is one of the program outcome itself, is OB framework. Therefore, we have to move away from traditional framework to OB framework. That is the fourth reason. And fifth, to make students more employable by equipping them with knowledge and skills that are required by the employers. The diagram you tried to recollect earlier, who is a good engineer? One with good technical capability. Now, apart from technical capability, you should have leadership skill, communication skill, lifelong learning skills, then critical thinking skills, and so many things are required. So that is possible only if you adopt outcome-based education framework. So these are the 5 reasons why every institution in the country should adopt outcome-based education. Then briefly, let us look at what is OBE. OBE is nothing but outcome-based education, is a student-centered curriculum design and instruction model that focuses on what students can actually do after they are taught. Here, focus is on student. Therefore, it's called OBE is student-centric. Traditional method is teacher-centric. What we used to practice earlier is teacher-centric. But with the implementation of OBE, it becomes student-centric. We are more interested in what students can actually do after they study a course, what students can actually do after they complete a program. So therefore, we call them as course outcomes. At the end of the course, students will be able to do. At the end of the program, students will be able to do. So therefore, OB focuses on students. It's student-centric. It focuses on what students can actually do, not what teacher has taught. You might have taught many things, but ultimately your effectiveness of teaching is judged by what students can actually do. If students cannot do, then our teaching is ineffective. We might have covered the entire syllabus. We might have covered all the 40 allotted lectures. But if students are not able to do, that means our teaching is ineffective to that extent. Therefore, we say OB shift the focus in education from teaching to learning. Earlier, we used to say that I have covered the syllabus, I have taken 40 allotted lectures, all questions in the examination that are covered. So always we used to speak with reference to teacher. Now the language changes. Now with everything with respect to learners. Whether students are able to apply knowledge of mathematics, science and engineering, whether they are able to use modern tools, whether they are to uh, a good communication skill, whether they are having teamwork skills. So everything with respect to students we start talking. So OB shift the focus in education from teaching to learning. In OB philosophy, the focus is on outcomes. If it is written at program level, program outcomes, written at course level. These program outcomes are nothing but graduate attributes. They in turn guide the content, the curriculum, teaching pedagogy, the teaching learning methods, and assessment at the examination. The, the program outcomes or graduate attributes, which are at the heart of the OB philosophy, they guide the curriculum, the content, pedagogy, and assessment. It is in reference to OB, it is different. Here it is the first model is co-written model. It is the traditional model where the teacher go to the classroom and he behaves himself as a sage on the stage, all knowing, and he thinks that his duty is only to pour his knowledge into the heads of the students. So it is called as pour it in model or traditional model. But whereas in OBE, teacher, you can see the degree cap. A teacher is also part of the students team. Okay, he is a part of the student team. So he gives knowledge as well as receives knowledge. Then you may say, what is that student teaches? Suppose you want to test students whether they have the ability to read and comprehend technical literature, which is part of communication skill. Then you download if there are 60 students, 60 paper related to the subject what you're teaching. Give one paper to each of the student. If it is not possible 60, then 30 you download. Give one paper to two students. Either 60, ideal. Then give 1 week time. Let the student read, understand, comprehend what is written. Then make one paper executive summary of the whole paper. What are the main objectives of writing that paper? What are the main objectives? Then what is the outcome? What he has learned? What he is unable to learn from reading that paper. Based on that, either he can submit a paper or he can give 5 minutes to come on the stage and speak to everyone. So during that time, listening to the student, you also as a teacher, you come to know many things about those 60 papers students are presenting. Out of that, some may be very relevant for you, some may not be relevant or relevant. You can mark and keep it for further study. So in this outcome-based education, teacher is also part of this teaching learning process. Therefore, it's called as keep it flowing. Okay, this is when you actually implement PBL, you will appreciate the diagram much better. Okay, then let us come to the main topic of the second session, that is understanding graduate attributes, competence and performance indicators. What are these graduate attributes? Graduate attributes are a set of competencies which are related to knowledge, skills and attitudes that all learners are expected to demonstrate. Okay, and then somebody may ask whether if there are 60 students, all 60 have to demonstrate? Yes, all 60 have to demonstrate, but they may not have to demonstrate at the same level. Some may demonstrate at higher level, some at medium level, some at low level. But something they have to demonstrate. They cannot say that I don't know anything about communication skill at all. Some may be good in oral communication, some may be average, some may be poor, but at least you know how to speak for 2-3 minutes. Okay, he may be doing mistake, but at least something he can demonstrate. Similarly, when he's writing a project report, somebody may do excellent way, somebody may average, some may poor, but he cannot say that I don't know how to write at all. Then that is non-compliance. So everybody has to demonstrate, but may not be at the same level. Then what are the components of these graduate attributes? One is knowledge, another skill, third is attitude. What this knowledge is? Knowledge is the fact our students know and concept they understand. So we teach so many facts and concept, laws, definitions. So if the students understand them and able to explain these laws and explain the definitions and reproduce some of the facts asked, then we say that he has gained some knowledge. But whether knowledge is sufficient? Knowledge is necessary but not sufficient. Why? Along with knowledge, students should be trained in skill also. Why it is? Let's take the example of engineer who has completed PhD in IC engines. Now a PhD has got a job, good salary, on EMI he has purchased a car, he has learned driving, he is going for a long journey. Now car develops some trouble and it stops. Even though he has done his PhD in IC engines, he knows everything about petrol engine, diesel engine, what is the combustion chamber, piston, crank, mechanism, everything he knows, whether spark plug used or injector is used, what is retardant injection, how advanced injection, how flame propagates, air fuel ratio, everything he knows. But now, because he lacks the skill, he cannot do it. He has to call some mechanic who comes on a two-wheeler. He's not even a graduate. He repairs the car and journey of this PhD holder continues. Why it happened? because this engineer is having knowledge, but he don't have the skill. Because of that, he is not able to apply his knowledge. Therefore, the 21st century employer asks, along with knowledge, skill also required. It is not just knowing the concept or the facts. The student should be able to apply that knowledge. Therefore, PO1 says students should have the ability to apply knowledge of mathematics, science, engineering, and engineering fundamental to solve complex engineering problems. Okay? They should not just knowledge, they should have the ability to apply that knowledge. That is the skill. So along with knowledge, they should also have the skill. Then why this third component, attitude, is required? Because this attitude dictates the goals toward which their skills and knowledge will be directed. They may be having knowledge and skills, whether they are going to use for the good of the society or bad of the society depends upon their attitude. Take example of computer science graduates, maybe with few years of experience also. They have the same level of knowledge and skills. Two groups, both have the same level of knowledge and skills. One will develop an app which will be useful for millions of users. So some people develop this uh, railway reservation app. Earlier, we used to go to railway station, stand in queue. We'll not knowing on the chart, we used to say display chart, you see something is available, it is green, something is not available, red. Depending on, you used to fill the form. By the time we reach the counter, the green will become red and reservation on that particular day not available. Again, we have to discuss, change the form. So much trouble. And sometimes you have to come back home and discuss with the elders whether another date is okay or not. But now it is not like sitting in the comfort at your home. You can decide the date, time, which class, whether lower berth, upper berth, middle berth, everything, and then book your ticket. So it is possible because a group of engineers who have the same knowledge, skill, developed this railway reservation app. On the other hand, another group which has the same knowledge and skill, they developed a computer virus, which will result in uh, hanging of desktop, laptop, or erasing the data, which will create a lot of nuisance for millions of users. Again, they themselves will develop antivirus and release in the market. So here, even though they have the same knowledge and skill, the group which is having positive attitude will do something that is good for the society. The one with negative attitude will uh, create problems in running of the organization. Therefore, 21st century employers look for knowledge, skills, and attitudes. So earlier I said there are 12 graduate attributes of program outcomes, and we can put them in four baskets. One is knowledge oriented, second is problem solving skill group, third is skill oriented group, and fourth is attitude oriented group. In knowledge oriented, we have engineering knowledge, PO1. In problem solving skill group, if you want your students to be good problem solvers, then focus on PO2, PO3, PO4. And if you want your students to be good in skills, then focus on PO5, PO9, PO10, PO11. Modern tool usage, individual teamwork, communication skill, project management and finance, these are all skill oriented group. And if you want to improve the attitude of your students, then focus on PO6, PO7, PO8, PO12. Engineer society, environment sustainability, ethics, and lifelong learning. So, uh, depending on in a particular semester, you want to focus on problem solving group. Don't try to attempt everything in one semester. So in one particular semester, problem solving skill group, another skill oriented group, another attitude oriented. Thereby, within 1 or 2 years, you will be able to develop better understanding of graduate attributes and move from a particular level that you exist to another higher level. Okay. Now, with lot of effort, internal discussion, you have understood what each are the expectation of each of the graduate attribute. Then you will design appropriate teaching activity, then through that you help the student to learn that competencies or develop that ability, so students' quality will improve. That is the idea. Don't try to do everything in one semester. So as I said, in 21st century, the employer expectation is all these program outcomes. The first 5 technical outcomes and these 6 and these 7 professional outcomes, all are required. If nowadays, if you want to be somebody who is a good engineer, one who is having all these technical outcome capability as well as uh, this professional skills ability. Okay, this slide we have seen again. So earlier I have said that some people have the doubt whether graduate attributes and program outcomes are the same or different. They are one and the same. You can use as synonyms. Where you want to use program outcome, you can write graduate attribute. Where you want to write graduate, you can write program outcome. They are one and the same. The graduate attributes as stated by NBA are in the spirit of program outcomes as stated in Washington Accord. Graduate attributes are referred to as program outcomes by Washington Accord. So they are one and the same. Exactly what is there in Washington Accord, the same sentences are picked up, including comma and full point, by NBA. So they are one and the same. Let us look at these graduate attributes or program outcomes and try to develop a little more clarity about them. Because ultimately, the program outcomes gives clarity of focus. Okay, so now here I'm going to refer to 3 sets of institutions. The first set of institutions who are more focused on compliance. Okay, I have PO1, I'm doing the compliance of that through this course. So they want to map the courses with the outcomes and show the attainment of the POs or program outcomes. Their focus is more of showing the attainment rather than developing deeper understanding of the POs. How these institutions will work or how the faculty member of these institutions behave. The first PO in the department, all of them sit together and look at this, apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. Immediately, the state says, oh, we have mathematics courses in our program, we have physics, chemistry courses in our program, and also we have basic mechanical engineering, basic electrical engineering, electronics courses like that. And we will map these courses with PO1, and PO1 can be shown as attained. That is the approach there. Second, problem analysis. Again, they go through this, identify, formulate, review research literature, and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences, and engineering sciences. Again, they say that we have certain courses. Since I'm from mechanical, I will take the example of mechanical only. Uh, I will take the example of mechanical, like fluid mechanics, heat transfer. There are certain problems before solving you have to analyze, otherwise you cannot solve. So they say that okay, these subjects like OR, fluid mechanics, heat transfer, we can map them, and also machine design, theory of machines. These courses will map with PO2 and show the attainment of PO2. Then it comes to PO3, design solutions for complex engineering problems and design system, components or processes that meet the specified needs with appropriate consideration for the public health and safety and social, cultural, societal and environmental consideration. They don't even read completely. What they say, like mechanical branch faculty say that we have machine design 1, machine design 2. Civil faculty say we have structural engineering 1, structural engineering 2. Like LE&C, they talk about electron system design. Like our students do, they code those name of the courses. So we'll map these courses with PO3 and show the attainment of PO3. So all these, their focus, emphasis on how to identify course and map the POs. That is their main target. Okay. Then when it comes to PO4, they look at design of experiment. The moment they look at experiment, they don't even read it completely. So every semester we have 2 lab experiment. We'll map all the lab courses with PO4 and we show the attainment of PO4. When it comes to modern tool usage, they talk about, oh, they have CAD tools, analysis tools, and some other tools or hardware tools. like coordinating measuring machine or some CNC machine. So we all these hardware tools and software tools we have, we'll map these courses with the PO5 and show the attainment of PO5. See, you can see all the technical outcomes are covered, but everywhere the teachers are not making any extra effort. All they're doing is identifying a course or courses in the curriculum and mapping them with the program outcomes. And they are getting satisfied with that. And when PO6, Engineer Society, so they have some problem here. And nowadays, many of the colleges, they started offering students projects, epics, something like engineering projects in community service. So that course they map with the PO6. And environment sustainability, as per Supreme Court order, they are teaching this environment science and Constitution of India and environment science. That course they show a map with this PO7 show the attainment of PO7. Ethics, some have problems. So if it is not part of a curriculum, what they do is they invite some industry expert or some expert from a spiritual domain and conduct a half-day workshop or one-day workshop, and then conduct a quiz and whatever the performance that map with this ethics, PO8, and some have really genuine good courses on ethics, professional ethics, and do good justice. But here, otherwise, most of the institutions, they just conduct half-day, one-day workshop, conduct a quiz and show the attainment of PO8. When you go to PO9, they say that all of students do final project in a team of 4 or 5, and during that they say that all this project work they'll map with the PO9. And when communication, they say we have seminar course and also at part of the final year project, the students do the presentation, they write a project report and also write laboratory journals. So PO10 is mapped with these courses and then they show the attainment. 11, project management and finance. Here what they do is they make the students to come out with a Gantt chart. So on one side there activity, another axis we have time. So this chart, activity chart, they prepare and also prepare a budget and put it in their project report. With such a simple approach, they say that the project management and finance management PO11 is attained. And finally, lifelong learning, many people don't have the clarity also. What they do is, in some of the courses, 1 or 2 chapters they don't teach. They say students to read and understand themselves, and they have to answer the questions in the examination from the questions from those chapters which they have not taught. And they say that the PO12 is attained. Some do even little better. In a project, they will ask students to do a particular software which they have not taught, and they say that students have learned the software on their own. And then they are showing the attainment, so now students are trained in lifelong learning. So here you can see this type of institutions, their focus is on only mapping. We have this course, this is mapped with this PO, and PO, that PO is attained. So with this, they continue to teach the way they are teaching. Only the students' performance, they map with the course outcomes, then with the program outcomes. And then they start complaining, even though we have implemented OBE in our institution, there is no significant improvement in the placement or employability of the students. So when your implementation process itself is wrong, how you expect the improvement in the employability of the students? Therefore, now I will give the examples of the second set of institutions, what they do. Here, I have taken the example of graduate attribute 10. This is about communication skills. And irrespective of the branch of engineering you belong, each one of you can understand what communication skill is. What these teachers in these institutions do is, they take one program outcome or graduate attribute at a time. They read all together only one PO. Communicate effectively on complex engineering activities with the engineering community and with the society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations, and give and receive clear instructions. So after reading, they spend a lot of time, sometimes multiple sittings on multiple days, to find out what are the expectations of this PO, what are the abilities this PO is communicating, And after that, they may identify the competency. One of the competency of this PO10 is students should be able to demonstrate an ability to comprehend technical literature and document project work. Okay. So once the student read a technical article, they should be able to read and comprehend what is there in that. Okay. And if they're asked to write a document on a project, they should be able to write. That is the first ability they should have. And second ability is, so this from where it came from this part, being able to comprehend, write. And they identified second competency, that is demonstrate competency in listening, speaking, and presentation. Communication skill does not mean only speaking. It is also about listening and giving good presentation. So this is the second ability they identified after reading the PO10. And the third ability they identified was demonstrate the ability to integrate different modes of communication. Sometimes now I am using audio visual. Okay, you are seeing my screen, you are able to hear me. I am able to use audio visual, multimodal communication I am able to do. So the student should also be able to do this. Okay, so when student have ability of all these three, then only we can say that he is good in communication skill. Whether it ends here, no. In the first stage, because it's a two-stage process, in the first stage you identified competency. In the second stage, you have to identify the performance indicators for each of the competency. Looking at this, we wrote the competency. Now looking at this, we have to write the performance indicator. Okay. So what is the indicator for this competency? Read, understand, and interpret technical and non-technical information. It is up to you whether you want to put non-technical information, but technical information should be there. Second, PI, produce clear, well-constructed, and well-supported written engineering document, be it laboratory journal, be it project report, mini project, minor project, or final year project. The third performance indicator, create flow in a document or presentation, a logical progression of ideas so that the main point is clear. When a third person read the document prepared by our student, you should make it very clear to him. The idea should be presented in a logical fashion. It should not be something written here, again something goes somewhere else and come back. So it should not create confusion in the readers. Okay. Whether it ends here, no. These people start spending now. Okay, this is the PO, this is the competency, these are the PI associated with competency. Then what is the learning activity I am going to propose to train my student in this performance indicator? For this, read, understand, and interpret technical and non-technical information. As a teacher, I will give, as earlier said, in my subject, I download the technical papers which are already published in referee journals and give one paper each to the student and give them a week's time to read, understand, and come to the classroom with the one-page report. Okay, with one-page report, or they can speak for 5 minutes. Okay, so when you give that assignment to the students, and then when they are giving the presentation using the rubrics, then you can mark them either they are good in reading and understanding technical information, or average, or poor. Similarly, about the second PI, whether they are able to produce clear, well constructed, and well supported written lab journals or project reports. Again, whatever the journal or report they have submitted, you can use the rubrics to assess it and then give the feedback. And third, create flow in a document. Again, you can, everything in the examination policy document, these rubrics are given. Okay, for each of the performance parameter, you have to write what is acceptable description and what is more than acceptable, what is below acceptable. Thereby, you can categorize your students whether they are exemplary or satisfactory or needs improvement, like that. Usually in rubrics, we don't use negative like fail, not good, like that. We say that needs improvement, satisfactory, or exemplary, like that we use, so that students will come to know in a classroom whether it is at a bottom level or middle level or at a higher level. Okay, this is how you can so somebody is asking quiz will come after a few minutes. Because in ORU session, there will not be quiz. In other sessions, there will be quiz, and this quiz will come after some time. Okay. So this is how for this PO, first, the second set of institution identify competency, then write performance indicator. For each of the performance indicator, identify a learning activity, then train the students in that, then they assess them for that. Similarly, for second, listening, speaking, and presentation, listen to and comprehend information. Instruction to viewpoints of others. So usually when they're doing discussing a point in the project group, you sit as a teacher, you as a guide, sit at a distance, observe them. Don't take participation in the discussion. So whether people, when somebody is speaking, whether others are paying attention to it or not, or when something is asked, whether they're answering or not, when some work had assigned in the previous week, whether they're completing that, coming or not. Based on that, you can uh, mark them about their attitude, about their ability to listen and comprehend, and also give their inputs. Okay, and when they are giving a presentation, are they effective in oral presentation? All those things you can assess using the rubrics. Similarly, demonstrate ability to integrate different modes of. So for that, performance indicators are create engineering standard figures, reports, and drawings to complement writing and presentation. When you're writing a project report, now, especially in mechanics, they have to draw different figures, the schematic diagram, the shaft, cut sections, all they have to, whether they have been drawn properly, particular first angle projection or third angle projection, whichever is prescribed is used or not, whether the dimensions are written properly or not. All this can be tested and accordingly given feedback to the students. And finally, whether they're able to use multimodal communication or not. So earlier what they said, when they look at PO10 first set of institution, PO10 we have final project, and in that they prepare project report. We have laboratory, they write project report, and seminar they give. So communication skill is taken care. That was the attitude. But here second set of institutions, they read, try to understand what are the abilities involved in it, call them competency, list them, and for each of the competency, write the performance indicator. For each of the indicators, that I come out with a learning activity, train the students, then assess. Now, can you see that there's so much difference in the approach? So, if you implement OB in this second way, definitely your students are well trained, they'll be more employable. So therefore, if somebody said we have implemented OBE and there is no significant improvement in our students, it only means that the implementation is not correct. You are error in understanding the graduate attributes and implementing it properly. Okay, this is second set. And third set, even it's possible, even though second set is good enough for majority of the institutions. But if you want to stand out from all the crowd, then you can go one step ahead. That I'm going to share what we did 10 years back. Quickly, I'll go through it because time is less. Program outcome analysis leading to introduction of new course. At that time, even we are not, the course outcomes and competencies are different. Course outcomes, you write yourself for your subject, whereas competencies are written looking at the program outcome. And these program outcomes are common to all the programs, civil, mechanical, computer science, PS, like that, E&C, electrical, BT. And once written in AIC examination policy document, this competency and performance indicator written, they can be used as it is by all the colleges in the entire country. Okay, okay. But if you think that you have the capability to modify the some of the competency and performance indicators that doesn't suit your program or the quality of students what you are getting, you can slightly modify them. There's nothing wrong in it. Therefore, we say guideline, not mandatory. So POs are mandatory, but the competency and performance indicators are written, they can be slightly modified. Either language, you can use a better language to understand, or you can slightly add some steps extra, or if you think that more, you can reduce them. So that flexibility is there. So these competencies are written for program outcomes, whereas course outcomes are written for different subjects or subject that you are teaching. Okay. What we did 10 years back, when we are not even member of Washington Accord, at that time we are referring to American ABET agencies outcomes, ABET outcomes. There also it was 3C means the criteria 3, that 3 stands. Just like in NBA we have 10 criteria. So there also they have certain criteria. The program outcomes comes for third criteria. And they used to define 11 outcomes. Now we are defining 12, 11 outcomes. So they used to call them A, B, C, D, E, F, G, H, I, J, K. So A through K means 11 outcomes. The C, the third one, is this: able to design a component system of almost it sounds with the present program outcome 3 or graduate outcome 3. That's why I selected. But our approach at that time, nothing was known to us. We learned the things hard way. So what we used to understand this, what we started breaking it. What it talks, able to design a component, write it. Able to design a system, write it. Able to design a process. So we broke the program outcome to understand better into 3 elements: element 1, element 2, element 3. Able to design a component, able to design a system, able to design a process. Okay. Next, what we did the gap analysis. What is presently practiced in our institution 10 years back and what is not. So at that time, I was the head of the Department of Mechanical. Now I am principal as well as Dean Academic of the university. So at that time, I was the HOD. I asked my faculty members, do we train our students in designing of a component? They said yes. So all our students in machine design 1 and 2, they know how to design a component. Are we training our students to design a system like entire drilling machine, entire lathe machine? They said no. Are we training our students to design a process? No. Any process design is taught in chemical engineering. Let us not bother. And anyway, there is a or is there. Either a system component or process. Anyway, since we are component we are doing, process we can drop. But system we are not doing, that is a gap. Then for each of the elements, we started identifying performance indicator and we were writing in our own way in those times the codes. The third C is the third PO, first element, and first PI code. So C1A, C1B, like that we were giving. Let us not give much importance because you are from different engineering disciplines, but only look at the process. We used to take one element at a time and together we used to discuss and write. Mainly the contribution from the faculty who are from design stream, who have done MTech in design, PhD in design. They used to contribute. They used to write these things. If the student has the ability to determine design parameter based on functional requirement, ability to design, identify design constraints, and establish the common design specification. If we demonstrate these abilities, then we can say he has the ability to design a component. Then what do you mean by ability to develop the component? If we do these things, because as I said, you are from different disciplines, I am skipping. I'm not going to read. Take one element at a time, write the indicators, and if student has all these abilities, then we can say that he has a ability of outcome element 2. Take the next element, write the indicators, and if student can demonstrate these abilities, then he has this competence of element 3. Okay, and we did not stop at this. Okay, then I gave them this template. Here is the program outcome. As I said, it is much before India became permanent signatory. We used to give our own code. ME stands for mechanical engineering, PO for mechanical engineering program outcome, C is the third outcome. This is what it is. Then outcome element 1, able to design a component. For that, this is the indicator. Education strategy means in which subject there is a content related to this performance indicator. Our teacher is to write, okay, in this subject there is a content related to this indicator. And given an option in which subject you want to collect the data. Collect the data means giving a question, making the student to answer, and then collecting the answers for different questions. So that is in which subject you want to collect. They used to write this. Then through which activity, either in asking question in assessment test 1, 2 or semester exam or PI specific, performance indicator specific assign, assignment problem. Then they said this was their choice. And at this point of time, is it a strength or a weakness? Then they said, sir, identifying functional requirement for a particular application is a weakness. We are not dealing with that in great depth. So it is a weakness. Similarly, second indicator, where the content is there, where you want to collect the data, what is the mode of activity, is it a strength or weakness? They said identifying design constraint is a weakness. Okay, because here they talk about really constraints. So, but we are not teaching our students correctly how to identify design constraint. That is a weakness. The next one, expressing appropriate units. They said again it is a weakness. Where they write only they don't write tolerance, they don't write surface finish, they don't write whether it needs heat treatment or not. So it is design specification not good. The drawings are very simplistic in nature. So that is a weakness. Then second element, its performance indicator, where the content is there, where you want to collect the data, what activity, is it a regular interaction with the guides. You may be experienced in the first month, they will be very much after the guide. When the problem is defined, they'll vanish. On the last month, they come with the project and fabricate the project and reports. It happens with most of the institutions. Okay, let us be honest in accepting it. So I said the regular interaction is a weakness. Then generating detailed drawing. As I said, the quality of drawings is not, they are not at all manufacturing drawing, that is a weakness. Then manufacture as per the approved design, check its specifications. Even though there are many courses, but the conformance of design specification, that is not at all checked. So usually what happens in many of the colleges, the students go to the workshop where many old projects are lying. If they want quarter HP motor, if the half HP motor is there, then they will to save the money, they take that only and use it. So where the question of conformance with the specification. So that was also a weakness. Then ability to design a system. The ability to design, recognize the desired needs. For system design, first you should know the needs of the customer. They said that now they are talking to the people, but they are not going with the well-designed questionnaire. That was a weakness. And as I earlier said, they were not knowing how to come out with a constraint. What is the cost constraint? What is the weight constraint? What is the size constraint? They are not aware. Only they were asking what is required. Then in their own way, they used to start up doing the project. Okay. Next, second is their ability to identify, understand important realistic constraint. That was the weakness. Then we said, let us do it. Anthropometry study and market study to identify the constraints. So in this way, what is required in a particular subject that cannot be extended to mini and minor project, final project that can be used as an opportunity also. Right now it is a weakness, but it cannot be converted into opportunity as well. Similarly, next we asked more than one solution. Then we said, let us use, in fact, the first time our teachers learned PUG evaluation chart and taught it. Till that time, they are also not aware about PUG charts. Then we not improve the interaction with the guides. We purchased project lifecycle management software so that whatever the student do at their place, that can be observed by the guide from his machine, so that he will come to know whether there is progress of project work or not. Then similarly, design, analyze and evaluate alternate solutions. Again, the PUG chart analysis was taught, which was weakness of identifying the alternative design. Similarly, fabrication, whether conformance or the realistic constraint were used or not, that was weakness. So we identified just with one PO, design and development of solutions. Okay, we identified so many deficiencies in our delivery, and there were so many weaknesses. Okay, if that was the weakness in our pedagogy, definitely the quality of students will also be at a lower level. Then we designed, because since we are autonomous, we had the option either to modify the existing course or introduce a new course itself. So what we did was we introduced a new project-based course. We give 10 credits, 4 credits for as a mandatory course, then 6 credits for doing a project for that course. Totally 10 credits because we wanted to do significant improvement in this PO3. So it was introduced at 6th semester level to address all the gaps. So we said at the end of the course, the student should become familiar with the steps of design a complete machine tool, not a component, a drilling machine or lathe or milling machine. They should be able to design. But again, we asked my faculty member, do you know how to design an entire machine tool? They said no. Then what to do? Then we identified and recruited a person from industry who had 30 years experience of design of lathe, design of drilling machine, complete machine tool. We recruited him. And he trained our faculty in the summer vacation for 2 months. Then there was a team of 5, 6 members. Then they started teaching this course. To draw the layout and kinematic drawing in 2D using appropriate software. Then preparation of assembly drawings as per industry standards. That is one of the objective. Carry out design calculation. So all this you can read. GD and TH symbols. The knowledge was missing. Again, this industry expert taught our faculty members. In turn, our faculty members started teaching it. Okay. Then how to prepare bills of materials in Excel sheet, how to use CAD software for preparing the 3D model, and also prepare the project report because one of the communication skills how to prepare project report as per the template. Now you can see after one semester how the drawing made by students quality changed. Now you can say the OB works. Okay, because we spent enough time in understanding that outcome 3. We identify the in which subject content is there and through what activity we can help a student to learn. We also honestly analyzed what is the weakness. We did not put anything below the carpet. We accepted, okay, this is the problem, this is the weakness, let us understand and to come out with a new course. And then we realized our faculty, existing faculty, don't have the capability to do that justice to that course. We recruited an industry expert who has 30 years of experience. Then with him, we trained our faculty. Now, industry expert and faculty together taught the students. Our students were doing this type of drawings as a group of 8. Some 90 drawings they used to do. When they did 90 drawings in one semester using the appropriate CAD software, the quality suddenly jumped. In fact, a couple of industries started visiting our institute only because of fact our placement officer started carrying these drawings and showing them this is the capability of students, mechanical students, and they come and started recruiting those students. Okay. So this is how proper understanding graduate attributes and then making proper analysis and then coming with a teaching learning strategy and then uh, teaching that course will result in such a fantastic results. Okay. Now we can say we have moved from component level to system level. Now our students can design the entire machine itself. Okay. Now the first quiz will come. Earlier I said there are 12 graduate attributes. Now, and also showed they fall into 4 baskets. In the first basket, which number? You can simply type the number of the graduate attribute. Okay. So in the second basket, what are the numbers of graduate attributes? In third basket, skill oriented group, which are falling, and attitude oriented group, which are falling. So you can type in the chat window. So in the first group, GA1, okay, that's correct. In the second group, so these are the quiz. No, in group 1, 2, 3 will not come. In group 1, only 1. In group 2, 2, 3, 4 will come. Okay. So all this will be recorded. Even your answers are recorded. Group 3, design and development of solutions. Group 3, skill oriented, skill. Modern tool usage is a skill. Individual and teamwork is a skill. Communication is a skill. Project and finance management is a skill. Okay, attitude oriented group. Engineer society, to know what is the impact the engineering projects will have on society. It all depends upon the attitude. Environment sustainability. The solution what I propose, what is the effect on the environment? It depends on attitude. Ethics definitely on our attitude. And finally, lifelong learning. It also depends upon our attitude. So these are the answers you can cross-verify. Group 1, GA1, Group 2, 2, 3, 4, Group 3, 5, 9, 10, 11, Groups 4, 6, 7, 8, and 12. Okay. Thank you for your participation. Let us move. Competency performance indicators. Since I have already explained during my first session, I will not spend much time. Only when it comes to critical thing, I will explain. Otherwise, I will move through the slides. This already I have presented. Design is top-down, assessment bottom-up, and program outcomes are high-level generic, and course outcomes are specific to the course. There is a missing connect. Because of lack of clarity, the measurement what you are doing or assessment what you are doing is unrealistic. To overcome that, the exam reform policy document proposed two-step process to bring further clarity and specific to program outcomes. What are these two steps? In first step, one, you write competency for POs, and second step, for each of the competency, you write performance indicator. This definition also I have gone through already. So this, when you write competency, the competency acts as intermediate step to create measurable indicators. Okay. So there I have taken PO3 as an example here. PO2. For PO2, these are the abilities required. If student has to demonstrate PO2, then you should have these abilities. These abilities themselves are called as competencies. From where they come? By reading this only. Student should have the ability to demonstrate ability to identify and formulate complex engineering problem. Suppose if you take mechanical students who have learned thermodynamics, fluid mechanics, heat transfer, take to an industry where there's a furnace, and if the industry person say that the lot of heat loss is taking from the furnace, and if you measure temperature is 80, 90 degrees centigrade, so the lot of heat loss is taken, then students should be able to identify and formulate a complex engineering problem. They should say that the skin temperature of furnace should not be more than 60 degrees centigrade. Okay. Then you should have the ability to formulate a solution plan. How? Whether you want to increase the thickness of insulation, or whether you want to use different material for insulation, and whether you want to change the cooling medium, what you want to do. Whether you want to use different types of bricks which are more heat resistance, or whether you want to repair the cracks, whatever the solution plan, you have to come out with alternate solutions. Then you should be able to formulate, come out with a mathematical model, the heat transfer equation for conduction, convection, radiation, all together you have to prepare a mathematical model. Then you should have the ability to execute a solution. So when the students are trained in this way, then you say you are training in PO2. It is not asking some question in fluid mechanics and then say we have PO2 is attained. You have to think of a situation, scenario, where you help the student to design, come out with the definition of a problem, then formulate a solution plan, come out with a mathematical model, and then solve it. Okay. Then having done that, then they should also define performance indicators. So these becomes a measurement tools for each of the competencies. They can also be designed to determine appropriate achievement level. So it is possible to set the questions at different cognitive levels. If input to your college or program is very good, if your college is in metropolitan cities, you can set the level at a higher level. But if you're in a rural area, it doesn't mean that students in rural areas are weak. No, but if you feel so, then you can start at lower order thinking skill. Then you can take 1 or 2 semesters extra to reach the higher order thinking skill. It doesn't mean you can get stuck with lower order thinking skills only. Okay, so never misread what I'm saying. If you feel that your students are already at higher level, then start with higher order thinking skills. If you think that the input quality to your institution, your program is slightly at a lower level, then you can start at lower order thinking skill, then move up. Take little 1 or 2 semesters extra to reach what your counterpart in the metropolitan cities are attained. Okay, take 1 year or 2 year extra doesn't make much difference. Ultimately, direction in which you are going is important. Okay. So, for one of the competence, the ability to identify and formulate complex engineering problem, the performance indicators are written like this: articulate problem statement and identify objectives, identify engineering systems variables. You should know which is the dependent variable, which is the independent variable. Okay. For the problem, the student is going to define, then he should be able to come out with a mathematical model, okay, to solve, because we say that when a complex engineering problem, it should demand use of uh, physical laws as well as use of mathematical techniques. So if you have this mathematical model, you can use the numerical solutions, techniques, and solve it. Then in model question paper, you will come across PI code. What is PI code? Performance indicator code. From page number 15 to 19, in the AICTE exam for policy document, you'll see these things. So 1.2.1 means program outcome 1. 1.1 means the first competency of PO1. 1.2 means second competency of PO1. 1.4 means fourth competency of PO1. And similarly, 1.1.1 means first performance indicator of first competency of first PO1 of PO1. Like this, 1.2.1 means first performance indicator of second competency of PO1. That is how. This third digit refers to performance indicator, middle one refers to competency, the leftmost number refers to program outcome number. So 15 to 19 are for all UG programs except CSC. Okay, the another example of PICO 2.1.3. The 3 refers to performance indicator, middle one for competency, and 2 for the leftmost refers to program outcome number. So third performance indicator of first competency of PO2. For CS, you have to refer page number 29 to 33. But here there is a printing mistake that you have to correct. You know that whenever the bullets are copied and pasted, numbers will change. That is what has happened. Before printing, they should have done some proofreading. It has missed somebody's attention. So if it PO1 means it should be 1.1, first competency. Second competency is 1.2. Third competency 1.3. Fourth competency 1.4. Instead of that, 1.2, 1.5, something have been printed. Correct them. Similarly, here, if it is 1.1, first performance indicator should be 1.1.1. Second should be 1.1.2. Second performance indicator of first competency of PO1. Like this, if you are doing in the project report, in the content sheet, if you are doing the 1.1, 1.1.1, it is something similar to that, preparing the content sheet. So first performance indicator of first competency of PO1. Similarly, first PI of fourth competency of PO1. Once you understand that, then looking at the PI, we should design a question. Actually, this arrow mark should be this side. We should have a PI. In order to show the attainment of PI, we should come out, ask questions to students. But why we are showing like this? First question, then arrow and the performance. Because most of us in India, we lack experience of providing industry consultancy. So when we are not giving industry consultancy, the exposure, real world exposure in our own subject is not there. So therefore, most of us, we are unable to define our own problem for a particular PI. So what we are doing is, in order to overcome this problem, look for a textbook written by the people with industrial experience. And from that, pick up the problem which suits these PIs. And train the students in solving such problems. Therefore, the PI is addressed. Through PIs, competency is addressed. Through competency, PO is addressed. That's how the quality starts improving. Again, another question related to another PI. Now, instead of drafting the question by ourselves, what we are doing is we are selecting a question and selecting from page 15 to 19 or 29 to 33, we are identifying appropriate PI suitable for this question. So this is how it is done. Then we are connecting them using a two-step process. First is PO. For PO, we write competency. For each of the competency, we write performance indicator. And then we connect this performance indicator with the assessment question. Take example of PO1, able to apply knowledge of mathematics, science, and engineering, fundamental to solve complex engineering problems. There is competency 1.1, 1.2, 1.3. Just for a discussion, remember 1.1 may be competency of mathematics. Competence 2 is for science. Competency 3 is for engineering fundamentals. Now, earlier what used to have, and in mathematics also there may be many PIs, one related to this linear algebra or calculus, another is mathematical modeling, third is ability to apply Laplace and Fourier transform. If you are interested, you can write one more PI about probability and statistics. Okay, like that you can write. This is the ability of physics, ability for science. This is for basic electrical engineering, mechanical engineering, civil engineering, or electronics engineering, that you can write. Okay. Now, you have to connect this PI with the assessment question. Whether question is asked in continuous interval evaluation, semester and examination, project or lab, wherever. There you have to connect the PI with that. So we are teaching 35 to 40 subjects from first semester to 8th semester. Then we are asking so many questions, and these questions should be connected with the PI. Because PIs are explicit statement of student outcome, and also questions are very explicit about our expectation. So they can be connected. Okay. Now, what was happening earlier when two-step process was not used? There was a subject, let's say it's a mathematics course related to calculus. Whether you write 4 outcomes or 6 outcomes, all the outcomes are related to calculus only. They are related to math and related to calculus, specifically calculus. Okay, and you are asking questions either in CI or SCE, either CO1, CO2, CO3, CO4, but subject is calculus, single variable calculus. All COs are related to calculus. All questions, whether you are internal assessment test or semester exam, are related to calculus only. Then they can be mapped with only one PI, because this PI is about calculus. Second is about mathematical modeling. Third is about able to apply this Fourier or Laplace transform. So all the questions, okay, were about PI 1.1. But what we are doing, even every CO you are connecting PO1. Hey, see, the CO1 is related to mathematics, and PO1 there is mathematics is there. Connect PO1. PO1 is attained. But now if you use two-step process for this PO, mathematics is one competency, science is another competency, engineering fundamentals third competency. In mathematics, calculus is one competency. Whether you ask question related to 1 to CO2, CO3, CO4, all are related to PI 1.1.1 only. Mathematical modeling is not satisfied. Fourier and Laplace are not satisfied. If there is one more about probability, that is also not satisfied. When this competency of mathematics itself is not satisfied. Question of PO1 getting attained is not at all there. So this clarity is possible only when you define competency PI. Otherwise, what happen? Ask any question in mathematics or physics or chemistry or basic electrical engineering, then connect the CO directly with the PO, because these two steps are not there at all. Question CO, CO to PO. CO is attained, PO is attained. But now we'll come to know that, so my students are good in calculus, but they are weak in mathematical modeling. They are weak in Laplace and Fourier transform. Now what I should do? Whether there is a content related to mathematical modeling, whether I have to modify the syllabus or bring in a new subject, then so that I can train students in mathematical modeling. I can train in Laplace and Fourier transform. I can train in this probability statistics. In this way, this two-step model tells us where the gap exists. Then we take appropriate steps, either modifying the existing syllabus or bring a new course. These gaps can be bridged and quality of education improves. Students become more employable. Therefore, we say using the two-step method brings a clear understanding of the expectations of each program outcomes to both faculty and students. The connecting course outcomes, CO to PI, and hence to POs will be made easy and accurate. Okay, this is first we connect course outcome, question with PI, then PI with CO. If it all PIs are satisfied, then this competence is attained. If all PIs are attained, then this competence is attained. When all PIs, then this competence is attained. When all competence are attained, then only PO1 is attained. Okay, so that clarity comes. So you know how to write course outcomes from this workshop, referring to exam reform policy document. Try to identify performance indicator, connect it to the examination question that you ask. The exam question should be mapped with PI, not with CO directly. Okay, so then you can see whether when you look at a question, whether all PIs are met or not met, unmet. After that, calculate the attainment of course outcomes. So still many institutions, PI attainment is they are not calculating. Only they are seeing whether all PIs are met or not met, whether questions are there for PIs or not. But when it comes to calculation of attainment, they are doing course attainment as well as program attainment, because it will take time. It is a new technique that is introduced. So people to understand, gain mastery, it will take some time. So even in your, if your NBA accreditation is due, if you express the knowledge of performance indicators, and then if you say that you have taken care that in the 35-40 courses that you are teaching, you have addressed all the performance indicators, but you have calculated only attainment of course outcomes and program outcomes, it's okay. By mapping examination questions with performance indicators, we get clarity and better resolution for the assessment of COs and POs. So the second, and we are coming to the end. This review questions you answer, then we'll, with a little question answer, we'll end it. These are the questions you can answer. Type your answers. OB stands for outcome-based education. OB focuses on teaching or learning. So many of you are writing learning. In OB, student is active or passive? Active, okay. OB is student-centric or teacher-centric? Student-centric, many of you are asking, answering. What are the advantages of becoming permanent signatory of Washington Accord? I said 2. Recognition of degrees. Good. And mobility of graduates. Then the 5 reasons for adopting OBE. Very brief, you can write. So you want to be competitive at global level. You want to retain the Washington Accord membership. Okay. Many of you are giving the right answers. So because of the time, I'm giving you the answer. So 5 reasons: globally competitive, permanent signatory of Washington Accord, NBA accreditation to build learner competencies and equip students with knowledge, skill, and attitude required by the employers. The 7th is, after attending these 2 sessions, are you convinced about the need for adaptation of OB framework in your institute or college? It may be yes or no. Yes, yes. Okay. Okay. The last quiz of the day. So 2-step process is proposed to enhance resolution of POs. Okay. The 2-step method brings a clear understanding of the expectation of each program outcomes to faculty and students. Yes. Is there any guideline regarding number of competent PIs? No. So I said these are guidelines, you can increase or reduce or modify these competence in PIs and prepare your own document. Okay. Different competency would generally require different assessment measures. Okay. A realistic observability and measurability of the POs at course level is very difficult. Very difficult. Connecting course outcomes to performance indicators and hence to POs will be easy and accurate. Anyway, you are giving the right answers. You can check. So this was the last quiz of day. Anyway, at home you can try for this. You start preparing the model question paper for a subject for which you are teaching. Today only you start, because tomorrow by night you have to upload. So if you are teaching thermodynamics or heat transfer or structural engineering, signals and systems, whatever university question paper, if you're autonomous college, your autonomous college question paper as per the format of your own university or institute, you prepare a question paper, but only see that you address the higher order thinking skills also. Not all 1, 2, 3, 4. So this is all about today's presentation. If you are interested, and it is very successful, I really thank, even at this point of time, even though it is little over 2 o'clock, more 623 participants are present. Really one of successful workshop, I can say, in recent times. So if you have any questions, you can ask. Already you attended the quiz. Okay. So there was one question how to attend. So answer, if you have any doubts or questions, you can ask, or else you can keep for tomorrow. That is also okay. If you are hungry, if you want lunch break. So thank you for your appreciation also. So your appreciation motivates us to deliver much better. So for MBA programs, only I can tell right now competencies and PIs are not defined. So you have to search in the internet, and if there something is available, with that as a reference, you have to sit at your own department, write whatever comes to your mind to the best of ability. Because when nothing is available at national level, so your best efforts will become input for others. So you will become a role model for others. So tomorrow at 10:30, first my colleague Professor Kotu Shettar will start. He will address about Bloom's taxonomy, and then how at each of the level questions are asked, and how to design a question paper, how to make use of Bloom's taxonomy in design of question paper. And in the last session, fourth session, I'm going to brief you about design of model question papers and little more clarity about this PIs and competencies. Okay. Then some inputs for question paper preparation. And third day, it's all about you. Myself and my colleague will only be listening to your presentation. You are sharing your, we'll make you one by one the panelist. You will share your design question paper, and you will explain why you are assigned Bloom's like taxonomy level 2 or 3 or 4 or 1. Then why you are mapped with particular PI code. And it will be open discussion for everybody. In discussing these papers, everybody will develop better clarity. That is the idea. So there is no presentation third day on from our side. Presentation will be only from your side on third day. Today and tomorrow we will present. Okay. Thank you. Thank you very much. Have a great day. Tomorrow we'll meet at 10:30 sharp. Thank you.